What's up, everybody? It's Dan from sagemathtutoring.com, and this is another video going over the kinds of SAT math problems that you might have to face on the SAT. This is a video that specifically highlights the calculator section where you are allowed to use your calculator. So if you're going to attempt any of these problems, you might want to have a calculator with you. So I'm going to dive in right now with problem number 1. So the graph above shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is closest to the time she finished lunch and continued her hike? So it's good to just get a general idea of what the heck is even going on with the graph. Just make sense of it really quick, obviously, So obviously time's on the bottom, the x-axis. And then there's this distance from her campsite. And basically, whenever, somebody stops 30 minutes for lunch or something, or, I've seen problems like this before where it's like they stop for an hour or whatever. That's always a sign that you want to look for a flat line somewhere in the graph. And the flat line is right here. So this is basically where, as you can see, time went by, but no distance was covered, right? There was no change in distance, which means that she literally just kind of hung out for a little while and didn't move, and then time went by, correct? So the real question is, based on the graph, which of the following is closest to the time she finished lunch and continued her hike? Well, she started to take a break a little bit after 1 o'clock, and then as she got closer to 2 o'clock, certainly past 1:30, that's when she resumed her hike. So that's why answer choice C is the answer. All right, not much arithmetic involved there. This is, pure interpretation of the graph. Okay, moving on. The table above shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability the winner will be either a female under 40 or a male age 40 or older? Okay, so before I dive in, let's make sure we understand the table. The matrix is such that you have male and female here, under 40, 40 or older, and then you have all the totals on the bottom, right? Okay, so that's a very common way of setting up a table with, these different variables like that. So I think the first thing we want to take note of is it's a probability question. So probability is always going to be desired over possible, or I could say want over possible. So I'm going to write that. So probability equals want over possible, meaning, the probability of something is a fraction, where in the numerator you have the thing that you're analyzing, the specific circumstance that you want, or the specific circumstance that you're analyzing, over all the possible outcomes that could occur, okay? Now the word or right here, it says the winner will be either a female under age 40 or a male age 40 or older. Now the word or should make you think in terms of addition, which I'll kind of explain a little bit better in a moment. But just know that when you see or, that means that you're going to take, the outcome here, and you're going to add it to the outcome over here. So we have an outcome called female under age 40. The word or means we're going to add it to the outcome of a male age 40 or older. So taking a look at that sets up the following probability. I'm going to write P for probability. And the question is, how many, within this table, how many of the first thing do we have? Either a female under age 40. Okay, female under 40 is right here. So this right here is an area of interest. So it's certainly going to be, 8 plus the other thing, which is a male age 40 or older. Well, that's right here. So that is of interest right here. So we're going to add that. And then, the possible outcomes are literally denoted here, right? This is the total 25 people. I mean, we could have used that too, but we could also use this bottom right-hand figure right here. So that is a figure that is of interest as well, because that's all the possible outcomes, because there's literally 25 people that we're pulling from, right? So there's 25 possible choices, and these are the choices that have to do with what we're honing in on, which happens to be females under age 40 and males age 40 or older. So we will put the possible underneath like that. And then, of course, that becomes 10 over 25. Now, there might be a temptation to reduce this, but I actually see 10 over 25 right here. So that's the answer. All right, let's say you were in the habit of reducing this. This would become 2 over 5. And, there's a possibility that the test would have put 2/5 here. So just to keep that in mind. So happens they did not reduce the fractions, and you're left with 10 over 25. Okay, next. Okay, so the graph below shows the total number of music album sales in millions each year from 1997 through 2009. So before I read the rest, I'm just going to look at this. Sales are here, years since 1997. So that's important to realize. These are the years since 1997. So, for example, 0 is 1997. 1 is corresponding with 1998. 2 corresponds with 1999, and so on. Based on the graph, which of the following best describes the general trend in music album sales from 1997 through 2009? Well, again, this is 1997, 99, 2000, 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe. Let's try it again. 1997, 98, 99, 2000, 2001, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is actually 2009. So when they say that, they mean the whole thing. Just sort of double checking that. Well, just casually speaking, if we want to talk about the general trend, rather than me look at the answer choices, I actually am going to kind of put it in my own words. The music album sales increased till about here. They dipped and went up, and then they went down, right? So let's take a look. Sales generally increased each year since 1997. Yeah, clearly that's not true. I mean, if that was true, then we would see an upward trend, right? Sales generally decreased each year since 1997. I mean, that's kind of tempting. I mean, it kind of did decrease overall, but there is that hump right here. Sales increased till 2000, then generally decreased. All right, let's see. 2000, this is again 97, 98, 99. 2000 is right here. So that corresponds with this. So basically, according to answer choice C, sales increased until 2000 and then generally decreased. I would agree with that one. C is definitely the most tempting choice so far. Sales generally remained steady. That's definitely not true. Did not remain steady. Answer choice C is the answer. Now again, crucial insight, 2000 corresponds with number 3. Okay, so just make sure you're aware of that. Moving on. The table above shows some values of the linear function f, which of the following defines f. So, okay. Yeah, so you have a list of choices here. These are all linear, meaning, they're presented, or they at least could be presented in y equals mx plus b, that sort of y-intercept form, where this is, one way of writing a linear equation. If you were to graph, something that takes this form, it would be a line, and the m would be the slope. So basically, the slopes are all presented in the answer choices, right here. That's a slope, that's a slope, that's a slope, that's a slope, and really the slope over here is 1. And why am I focusing on the slope? Well, the reason I'm doing that is because one thing I noticed about the answer choices is that all the slopes are different, and therefore if I could just find the slope of this line, this line that the table is describing, then I could find the answer, right? If I could just find the slope, then I would know what the answer is. So let's actually go on a separate mission, or on an interesting mission right now, to find the slope. And let's remind ourselves the formula for the slope is most definitely m for slope equals y2 minus y1 all over x2 minus x1. This is something you definitely want to know for the SAT without question. And basically all I have to do is choose 2 points. I do not want to deal with this negative, so I'm going to choose these 2 points right here. So we have a point called 3 comma 4, and we have a point called 2 comma 1. And in case that's not clear, please understand that this is sort of like the x coordinate row, and this right here, I know it says f of n, but that's really the y coordinate row. You could temporarily think of it that way. All right, so we have 2 points on our hands. We have one point called 2 comma 1, and we have another point called 3 comma 4. I'm going to write those down right now. We have a point called 2 comma 1, and we have another point called 3 comma 4. And all we have to do is simply use this slope formula, and we will be able to absolutely, find the answer. So m equals, and it's going to be y2 minus y1. Well, it might be helpful to actually label these. This would be x1, y1. This would be x2, y2. And, I like to just do parentheses, so I'm just going to write the parentheses right now. I know it's going to be something minus something all over something minus something. And then as far as this is certainly going to be y2. Well, where is y2? It's 4. So we're going to put 4 in there, minus y1. Well, y1 is 1. Over here, we're going to have x2 minus x1. x2 clearly is 3. So we're going to put 3 there. And then x1 is 2. So we're going to put 2 there. And then m, therefore, equals 3 over 1, aka 3, right? So the slope is 3. And there's only one answer choice where the slope is 3. Answer choice C is such that the slope is 3, so that's the answer. Moving on. At Lincoln High School, approximately 7% of the enrolled juniors and 5% of the enrolled seniors were inducted, blah, blah, blah. I don't care about that. If there were 562 juniors and 602 seniors, which of the following is closest to the total number of juniors and seniors at Lincoln High School inducted into the thing? Okay, so basically all you have to do here is, number one, associate 7% with juniors, and there's 562 juniors. Associate 5% with seniors, and there happens to be 602 seniors, right? So basically all you have to do is find, okay, well, what is 7% of the 562 juniors, and what is 5% of the 602 seniors? And then whatever those numbers are, you just add them together, because we want to, we want the total number of juniors, and the total number of seniors inducted into this National Honor Society. So this is just sort of testing your ability to remember how to find percentages. This is certainly where a calculator would come in handy. If we want to know what is 7% of 562, you could always think of it in terms of the verbal aspect, where you could literally think to yourself, what is 7% of 562? And the other question to ask yourself is, what is 5% of 602? That's a good question to ask yourself. Now, these are two questions that could be translated into algebra. Now, there's another way to find percentages that have to do with like a proportion, but this is actually my favorite way. I literally just think of the question I'm asking myself, what is 7% of 562, Well, that gets translated into the following. What means X, is means equals, 7% means 0.07. The word of always means multiplication. 562 is just 562. So let's translate this also. We have what is X, is means equals. 5% is 0.5 of means multiplication, and 602 is just 602. And definitely using a calculator here, we would realize that X is 39.34. 39.34. And let's just draw a box around that to draw attention to it. And over here, if we were to multiply 0.05 times 602, we would have 30.1. So X equals 30.1. Now, it might have been smarter for me to not use x for both of these. It might have been better for me to use x over here and maybe y over here. But nonetheless, 7% of 562 is 39.34, and 5% of 602 is 30.1. And we want to know the total number of juniors and seniors that got inducted into National Honor Society. So all you have to do is add these. And when I add 39.34 to 30.1, I can already see that that's basically going to be about like 69. So this is the answer. Moving on. All right, which of the following is the sum of the two polynomials shown above? All right, so don't get thrown off by the weirdness of this if you haven't taken Algebra 2 or whatever. It's really such that you can employ like just basic algebra principles where, the sum, what is the sum? Well, we're adding these, right? They were kind enough actually to stack like terms over like term, like term over like term, like term over like term. So you can just literally add like straight down. And it's the case that 3x squared plus 5x squared gives me an 8x squared. And then we have the negative 5x minus 2x. Well, that certainly gives me a negative 7x. And then we are done because the only one that this could possibly be is A, because this says plus 7x. We don't want that. This is x to the fourth, so these are out of here, right? So this is a nice example of like just process of elimination, also. I could have been like 2 plus negative 6, and that would have been a negative 4 over here, but I didn't have to. The moment I had these two terms, I knew that the other ones didn't work, and I could move on. All right, if 3/5 W equals 4/3, what's the value of W? All right, so this is, kind of, in a way, basic algebra, I suppose, where, the real question is, okay, I want to solve for W, but I have this fraction coefficient. How do I get rid of the fraction coefficient so that I could have W by itself? Because at the end of the day, when you're solving for W, that basically means that you want W equals blah, 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 blah. You want the W to be by itself, and it's just some number on the other side. So the question is, how do you do that? Well, the way that you get rid of fraction coefficients, the best way, in my opinion, is to simply multiply by the reciprocal, right? Which is essentially, dividing by 3/5. But it might be easier on the brain to just think of it as multiply by the reciprocal. Just stick with that sort of rule of thumb. And the reason for that is because you cancel. There's a cross cancellation there, and there's a cross cancellation there. And you end up with W equals, whatever this product is. Now, this product should be fairly easy. There's no opportunities to cross cancel, so we are going to have to just multiply straight across, which really isn't that bad. Multiplying fractions is really easy. You can always just multiply straight across if need be. So 4 times 5 is 20, and 3 times 3 is 9. We are done. That is the answer. Let's find it over here. There it is. Yay. Boom. Moving on. The average number of students per classroom at Central High School from 2000 blah 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 can be modeled with the equation that, where x represents the number of years since 2000. Okay, great. That's important. It's always important to realize like x represents the number of years since 2000, which basically means that when x is 0, that is the year 2000. Okay, so just make sure that's clear. Y represents the average number of students per classroom. Which of the following best describes the meaning of the number 0.56 in the equation? Okay, so I think before we get into like interpreting this and understanding, well, 0.56 means whatever, like you might want to get an idea of like the visual. Now, it's the case that, this is like the y-axis, that's the x-axis when you're like modeling like functions like that, sometimes it's helpful to, set up quadrant 1 when you're modeling real world situations, right? Usually quadrant 2, quadrant 3, quadrant 4 aren't really involved when we're modeling real world situations. So you just kind of set up the, first quadrant of the XY coordinate plane. And you might want to get a sense of, what's going on here. And it's the case that, I think for many good reasons, mathematicians have chosen the x-axis to sort of be like the time axis. It's not a bad idea to just immediately assume that the x-axis is going to be the one that represents the passage of time. Now that could be time in years, it could be time in weeks, it could be time in days, but usually the x-axis is the axis that denotes the passage of time, all right? And I'm going to make it a little bit of a nicer looking T because it looks like a stick figure and it's going to bother me. So that's the T. Now the reason I use cursive T is to make it look like something other than a plus sign, so it's clear that it's a T. All right, so then it's like, years since 2000. So this is going to be time. This is going to be years since 2000. And Y represents the average number of students per classroom. So over here, I'm going to just write S for like students per classroom. Now, apparently, if I was to graph this, it would be like 27.2. And then apparently the slope is 0.56, which is really 56 over 100, right, if you think about it. But the y-intercept is 27.2, and it's a positive slope, so it goes up. So I'll just put like 27.2, on the graph, like right. Fill that in a little bit. We'll put that 27.2 like right there. And I'll just write that 27.2. And again, that's the y-intercept, and according to the problem, we can clearly see that it starts at 27.2 as the y-intercept, and then it kind of goes up from there, right? Right. So anyway, what do they want? So 27.2 is right there in case you can't see it. The writing's kind of small, but I'm trying to really squeeze everything in here. So nonetheless, let's see where x represents the number of years since do that. Which of the following best describes 0.56? So 0.56 is really 56 over 100. And 0.56 is the slope, right? It's the slope. So another way of thinking about the slope is the rate of change, okay? So you just have to sort of have a loose familiarity with like what a slope means and what the y-intercept means. Let's be clear about the y-intercept. The y-intercept means that in year 0, also known as 2000, in the year 2000, there were 27.2 students, right? And then it increased from there. Well, how much did it increase? 0.56 students per year. That's how much it increased. It went up 0.56 students per year, also known as if there were 100 years going by, there'd be an increase in 56 students, okay? Might be weird to think of 0.56 students, like what does that mean? But again, it's the average increase of students per year, all right? So let's look for an answer choice that reflects what I just said. Total number of students at the school in 2000. Well, no, that's incorrect. There were 27.2 students in the year 2000. Average number of students per classroom in 2000. Well, no, in 2000 it was right here. The average number of students was like 27.2. So anyway, 27.2 is a number that sort of is associated with answer choice A and B. The estimated increase in average number of students per classroom per year. That's definitely the answer right there, okay? So this just has to do with your ability to sort of understand what this means, to get clear that that's the y-intercept, to get clear that that's the number of students that we had in year 2000, and to realize that 0.56 represents the rate of change, also known as the increase in number of students per year. All right, and it's the average number of students. Okay, this one, let's see. Nate walks 25 meters in 13.7 seconds. If he walks at this same rate, which of the following is closest to the distance he will walk in 4 minutes? All right, so there's numerous ways we could go about this. One of them would entail like a unit conversion string of multiplying fractions, which is an interesting strategy. I think probably for most students, setting up a proportion might be the easiest way to think about this. So for example, you can set up a proportion where it's going to be meters over seconds. Okay. Now, according to the information, clearly this person is walking 25 meters, 25, for every 13.7 seconds. And we want to know how much distance would he cover in 4 minutes. Well, meters is on top, so we could set this equal to x because we want to know, how much distance does he cover in 4 minutes. Now we need to represent 4 minutes down below, but of course we are using the unit of time measurement called seconds. So we need to convert 4 minutes down here into seconds, right? And that's pretty easy. 60 seconds in a minute, so it's going to be 4 times 60 seconds, right? That's how many total seconds we're dealing with. We're dealing with 240 seconds, right? So therefore, 240 would go here, and this is just a straightforward, cross multiplication situation where 25 times 240 is 6,000, and that equals 13.7 times x. In case you're not clear what I did there, it's going to be 25 times 240 first, and that goes here, and then obviously x times 13.7, which goes here, and clearly we need to divide both sides by 13.7, and that would give us 437.9. 437 point, really rounds up to 438, but it's 437 point something. Okay, now this is not here, but notice how they did say which of the following is closest to the distance he will walk in 4 minutes, and obviously that's 450, so that's the answer. Boom. Moving on. All right, refer to the following information. Okay, so this is a table from hell that nobody wants to look at. Let's get a sense of what's happening here. So the chart above shows approximation of the acceleration due to gravity in meters per second. Okay, acceleration due to gravity for the 8 planets in our solar system. The weight of an object on a given planet can be found by using the formula W equals mg, where W is the weight of the object measured in newtons, m is the mass of the object in kilograms, and g is the acceleration due to gravity on the planet measured in meters per second. All right, so I think it's like that last part that stands out as sort of arguably one of the more important aspects of this, where it's like g is the acceleration due to gravity measured in blah. Well, m over second squared is right here, so I think it's definitely worth noting that this whole column represents g, right? So I'll just kind of underline that in green, because again, g is meters per second squared, so that's, all this stuff, right? This is all g stuff. All this is g. And we're making that mental note that all of this is, corresponding with g. It's meters per second squared. Mercury does 3.6 meters per second squared. Venus is 8.9 meters per second squared, and so on. And that might come in handy because apparently the weight of an object on any given planet is measured by the mass of the object times g, and g is to be found here. So these are the things that you want to make mental notes of when you read the description and when you look at the chart. You always want to ask yourself, okay, how does the chart or table, relate to the description that they just gave me, and then move on. All right, so we're going to move on to the first problem now. So, looking at the first problem, what is the weight in newtons of an object on Mercury with a mass of 90 kilograms? Well, once again, they had told us what the formula for the weight is. It's W equals m times g. There it is, right? So if we want to know the weight of an object in Mercury, well, we know that we're going to be using W equals m times g. Now, they happen to give us the mass. They happen to give us m. It's 90, so clearly that's going to be W equals 90 times G, right? So then the question is, okay, if we want to find out what W is, if we want to find out what the weight is, well, what the heck is G? Well, that's where the table comes in, obviously, right? Mercury is the top row. G is 3.6, right? So this will end up becoming, 90 times 3.6, and that will give us 324. That is the answer. Very good. Moving on. An object on Earth has a weight of 150 newtons. So we have this weight formula, W equals mg. Now they're actually giving us the weight. They're giving us W. On which planet would the same object have an approximate weight of 170 newtons? Right. Well, that's an interesting one. We have to do like a little bit of a journey here. Okay, so an object on Earth has a weight of 150 newton. Let's try to extract as much information about this little object as we can. For example, let's get the mass of this object. So for example, if we're going to use W equals mg, well, the weight would be 150, and the mass we don't know yet, but we certainly should be able to figure out what G is because this is an object on Earth. Well, according to the chart, Earth corresponds with a G of 9.8, so that's going to be m times 9.8. Now, that is most definitely enough information to find out what m is. We're going to divide both sides by this 9.8, and that would give us approximately 15.3. So, we don't know everything about this object, but one thing we do know for sure is that it has a mass of 15.3, and we know that based off of the information they gave us in literally the first sentence. Now we want to know on which planet would this same object have an approximate weight of 170 newtons. Well, once again, we're going to, use the W equals mg formula. In fact, I'll rewrite it down here. W equals mg. And according to, the second part, it says, okay, we're looking at an approximate weight of 170 newtons. So it's 170 newtons. We already know the mass of the object in question is 15.3. So it's going to be 15.3. And now the mystery is, what is the G that corresponds with this object, with this mass, having a weight of 170 newtons, right? Now, if we figured out what G was, let's say G ends up being 14.1, well, we would know that it's, this row right here, and then we would know the planet. It would be Neptune, correct? So our real mission here is to find G. Now, I do want to say, we're about to do that, but I do want to say when it comes to problems like this, you might not know exactly how specifically to get from, the information to the final answer. You might not have the entire journey like flash in your mind with clarity, but one thing you could do is you could just extract as much information as you can from the first sentence and notice how that gives you the mass, and then kind of take it from there. Something about just doing one thing at a time and always asking yourself, okay, what information can I extract from this part? That could serve to lead you to the next step. It could inspire the next step, and then eventually it would enable you to make sense out of the rest of the problem. Okay, so all hope is not lost if you're not exactly sure what the heck is going on here. You just extract information and then take it one sentence at a time, really. Okay, so once again, we are going to find G, the G that corresponds with this object of this mass having a weight of 170. Once we find G, then we'll be able to use the table to figure out what planet we're on, right? Because that's the question. It's on which planet, right? That's the final question. On which planet? So, dividing clearly both sides by 15.3 in order to solve for G gives us 11.11111. All right, so G equals 11.1 repeating. Okay, so that's this row, and therefore it is Saturn Yay, Saturn. Saturn is the answer. Moving on. In the function f, if the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? Okay, function f, don't get thrown off by the word function. That just basically means it's like a graph that is such that it passes something called the vertical line test, which, by the way, you don't really need to understand that. But nonetheless, 5 distinct zeros. Well, what does that mean? Now, the word zero in the context of like a function, it basically means like the, moments where the graph crosses the x-axis. Okay, that's what a zero is. A zero is a moment where the graph crosses the x-axis. According to the problem, we're analyzing a function that crosses the x-axis in 5 distinct places, right? 5 distinct zeros means that our graph crosses the x-axis at 5 distinct places. That's what it means. So let's look at this one. This one crosses 1, 2, 3, 4. So that one's gone. Get out of here. This one crosses at 1, 2, 3, 4. Also gone. This one crosses at 1, 2, 3, 4, 5, 6. Too much. That one's gone. And by process of elimination, it's D. We are done. I could move on, but let's just take a look. 1, 2, 3, 4, 5. What do you know? That's the answer. Moving on. All right, crazy looking weird function. The equation above gives the height in feet of a ball t seconds after it's thrown straight up with an initial speed of v feet per second from the height of k feet, blah, blah, blah. Which of the following gives v in terms of h? All right, so it's that last sentence that really helps us see what needs to be done. Which of the following gives v in terms of blah, right? Anytime the SAT says, solve for v in terms of blah, 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 that literally means v equals what, right? So that means take the equation and get v by itself. So again, anytime they say, which of the following gives v in terms of all this other stuff, that's code word for solve for v, right? So let's do that. Let's write h equals negative 16t squared plus vt plus k. Now this is definitely, you're going to have to bust out your algebra skills for sure, and you're going to have to sort of like take a look. All right, well, this term does not have a v in it. This term does not have a v in it. This term does have a v in it. So we want to get this term completely by itself, right? If you're going to solve for v, you're going to want to at least get the term that has v in it by itself. So in order to get this term by itself on the right-hand side of the equal sign, we're going to leave it here. What do we have to get rid of? Well, clearly we have to get rid of this. We have to get rid of that. So I'm going to actually add 16t squared to both sides in order to get rid of this. And I'm going to subtract k from both sides in order to get rid of the k. I'm going to do those in one shot right now, just to sort of save time. Okay, now, could you do these steps separately? Sure, you could do these steps separately. So, give myself a little bit more room. So basically, anything I do to, one side of the equal sign over here, I have to do the other side. So this is going to be plus 16 plus, I'll do it in a different color, plus 16t squared minus k over here. Obviously these cancel, that's the whole point. Obviously these cancel, that's the whole point. And then we end up with just that vt, over here, because these are gone. And I end up with h plus 16t squared minus k. Now, I'm going to, let me just do that. So it's going to be h plus 16t squared minus k. Cool. Now we have this v times t. Now again, we're solving for v, so the t is now in the way, so we're going to get rid of that by dividing both sides of the equation by t. And clearly, these cancel. That's the whole point of dividing both sides by t. And then we end up with v equals this sort of ugly looking situation called h plus 16 t squared minus k all over t. And in a way, you could be like, all right, well, that's the answer. Done, because I just solved for v, so we should be done. But here's the problem. The problem is this doesn't really, resemble any of the answers, right? So we're going to have to do some other stuff with this. Well, the first thing I notice is that each answer choice features a specific order where it's like h, k, and then t. H, k, and the t's on the bottom here. But here's h, k, and then t. H, k, and then t, right? So let me just at least get this to resemble that aspect of the answer choices. That's, not the worst idea in the world. So, I'll just rewrite this whole thing. So it says v equals h minus k plus 16t squared all over t, right? Then we have h, k, and then t. So I at least can get it to resemble the answer choices a little bit more in that regard, right? So then the question is, what do we do from here? Well, one thing that sort of stands out to me is the fact that there's a t squared here, but there's no t squareds in the answer choices. So that means that somewhere along the line, in each of these answer choices, there was some sort of a cancellation with the t, one of the t's and t squared and this t down below, which makes me suspect that they must have done this thing where they, in a way, they separated the 16t squared over t from the h minus k over t. There was a moment where they did something like that. And what I mean by that is you should be able to rewrite this as h minus k over t plus 16t squared over t. Now, why am I able to do that? Why am I able to go from here to there? Well, for the exact same reason that I'm able to go from here back to there. Because think about it, we have a fraction plus another fraction. Not only that, these two fractions have the exact same denominator, also known as a common denominator. Well, what can you do when you have two fractions that you're adding and they have the exact same denominator? Well, you add them together by keeping the denominator, there it is, and adding this numerator plus this numerator. Well, that's exactly what's happening up here. So for the exact same reason that I can go from, here to there, I can also do this like splitting technique where I go from here to there. Now, why is that useful? That's useful because now I can focus only on this part. I can focus on this term, and I could do this cancellation where there's a t squared up here, which really means t times t, and one t down below. So basically, one of the t's here cancels with that t down below. In case that's not clear, let's go over here. 16t squared all over t. Well, 16t squared, that's really 16 times t times another t. And there's still that t down below. And one of these t's would certainly cancel with the t down below, leaving me with just a 16t up top, right? Just a 16t up top right there, right? And there'd be a 1 underneath. I don't really have to write that. That t turns into a 1, but we don't need to write 1 underneath there, okay? So this is such that one of the t's here cancels with this t down below. Now, the way that I'm going to write it is to just simply cross out the exponent of 2 and cross out the entire t right there, okay? That's the way that I like to write that process. So therefore, on the next line, we would have v equals h minus k all over t plus 16t, yeah? And now at least I've gotten rid of that exponent of 2, so that's one step closer to resembling the answer choices as well. And from that, hopefully, you can see that answer choice D is the answer. Okay, So that's what you have to do for that one. Moving on. Okay, the cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost in dollars for H hours of phone use? Right, so they're asking for hours when they gave you, like, the rate per minute, right? Well, you know, these answer choices are all supposed to be, potential equations that represent the total cost in hours. Yeah. So let's just forget about these for a second, and we're going to use, logic and reason and math skills to just take a look at the first sentence. Cost of using a telephone in a hotel meeting room is 20 cents per minute. Okay, just focusing on that and forgetting these for a second. Okay, if it's 20 cents per minute, well, how much money is it per hour, right? Well, how many minutes are in an hour? 60. So it's going to be, zero point 0.2, it's going to be 20 cents times 60. And that's going to give you the cost of a phone call per hour, right? So let's just do that. Let's just ourselves find the cost of a phone call per hour, because that's what they're sort of asking for at the end, right? So 0.20 times 60 is $12. So we totally, based off of this first sentence, totally just figured out, okay, if it's 20 cents per minute, well, obviously that means it's $12 per hour. So the question is, which one of these answer choices represents $12 per hour, right? Well, this one does, right? And in fact, that's actually what we did, right? Isn't that what we did? We multiplied 0.20 times 60. We did it right here, right? But we didn't, the reason I kind of did it separately is because I didn't want to get confused by all this. I wanted to just think about this sentence in isolation and ask myself, it's 20 cents per minute, how much is it per hour? Because that's what they're asking. So it turns out that this is the one that gives you $12 per hour. This does not. This does not. This gives you, I don't know, 3 something, So same with this. This is the one that, if I was to multiply 20.20 times 60, that would give me literally this equation. And in a way, this is the equation you might want to use if you want to figure out the total cost C in dollars for H hours of phone use. You might want to use this equation, but it so happens that this is equal to that. That's the answer. So I'm assuming y'all get it. I might be overdoing the explanation. So let's move on. In order to determine if treatment X is successful in improving eyesight, a research study was conducted. All right, so before I get into it, just know that this is a pain in the butt, big fat word problem that unfortunately is featured quite a bit on the SAT, like these kinds of word problems. A lot of reading, and it's just terrible because no one wants to read about any of this stuff. However, these problems are often way more easy than they appear. I know it looks dense and it's like confusing, but as a student, just know that there's a strong possibility that what they're talking about is super easy to understand. All you have to do is stay calm, focus, and just read one sentence at a time and just piece it together in your mind as you go, obviously, right? But I think my real point there is just don't get freaked out by this stuff. Just take it one sentence at a time. So, for example, in order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. So there was a huge population of people with poor eyesight. And of that huge population, maybe it was a large population of, 10,000 people or whatever, they randomly chose 300 people. Half of those participants, half of the 300 people, were randomly assigned to receive treatment X, and the other half, which is 150 people, did not receive the treatment, right? The resulting data showed that participants who received treatment X had significantly improved eyesight as compared to those who did not receive treatment X. Based on the design and results of the study, which of the following is an appropriate conclusion? So let's say you have a group of 10,000, we'll say 1,000 people. And then you studied 300 people. And you gave half of those people the treatment X, and the other half got nothing. I'll just do a little 3 dots for nothing. These people ended up having their eyesight improved, and these people unfortunately remained with poor eyesight. So just, it says, based on the design and results of the study, which of the following is an appropriate conclusion? So without even looking at the answer choices, let's ask ourselves, which of the following, what is an appropriate conclusion to make from this? I would say that the appropriate conclusion is that, it looks like the treatment might very well work, right? I mean, that's basically the conclusion. It doesn't mean that it works in every single case. It doesn't mean that it's foolproof, etc., but it looks like it works pretty good, right? There's reason to believe that the treatment is good for many people. That's the appropriate conclusion to make, right? So let's move on. Treatment X is likely to improve the eyesight of people who have poor eyesight. I like that one. That's a good one. So we're going to keep that one in mind. Answer choice B. Treatment X improve eyesight better than all other available treatments. That's a bit much, huh? That is a bit much. We don't know anything about other available treatments. We have no information. Not enough information here to make that conclusion. Answer choice C. Treatment X will improve the eyesight of anyone who takes it. Once again, not enough information. There might be some people, for example, a person over here, right? This person, maybe it would not have worked with that person, right? So answer choice C is gone. Answer choice D. Treatment X will cause a substantial improvement in eyesight. So that one's pretty tempting, right? It will cause a substantial improvement in eyesight. I think the problem with that one is the word will. Will implies that it's just certain that treatment X will cause, a substantial improvement in eyesight. Again, there could be some person in the group of 1,000 people who just, wasn't, didn't happen to get chosen randomly in that 300 person sample. It could be such that treatment X wouldn't work with that person, right? There's always a chance that there's other people who treatment X would not work with. So the word will, which implies certainty under all circumstances and conditions, is problematic here. Okay, so for that reason, answer choice D is gone. Answer choice A is the answer to that one. Moving on. Okay, graphs of the function f and g are shown in the xy plane above. For which of the following values of x does f of x plus g of x equal 0? All right, so it's helpful to think of f of x and g of x as being the y values of each corresponding graph, all right? And in fact, they sort of encourage you to think of it that way by saying y equals f of x and y equals g of x here, all right? Now, I'll just say very briefly that it's probably the case that a lot of students who have not taken Algebra 2 especially are not that used to function notation, right? Just understand that this is called f of x, and it is something that every now and then it's helpful to just think of it as another way of writing y, okay? Not always, but every now and then it's helpful to think of f of x as like y. Now, people who have taken Algebra 1 are a little bit more familiar with this scenario. So I just want to say, for the purposes of a problem like this, it's good to think of f of x as y. And again, the problem sort of encourages you to do so, right? So just keep that in mind. Now, let's really be detectives and analyze specifically what is happening here, they're saying which values of x along the x-axis are such that f of x plus g of x equals 0. So in other words, which of the following values of x are such that the y value of this function plus the y value of this function equals 0? Well, that would only happen if the y value here was the opposite sign version of the y value here. So for example, if the y value of f of x was 3, well, the only way that 3 plus g of x equals 0 is if g of x was a negative 3, right? So in other words, they want to know which values of x are such that the y value here is the opposite sign version of the y value here. Now, this could be a 2 and a negative 2. This could be a negative 2, and this could be a positive 2. As long as it's the same number, but opposite signs, that's what we're looking for, because that's the only way you would get 0. If you added the same number only with the opposite signs, to itself, right? That's how you would get 0, because 3 plus negative 3 is 0. 4 plus negative 4 would be 0. 5 plus negative 5 would be 0. Negative 5 plus positive 5 would be 0, and so on. All right, I think you get the point. So let us look at the graph and find out which value of x corresponds with that scenario. Okay. And we can sort of see already that, like, here's the origin. That's negative 1 and that's negative 2. So this negative 2 is of interest, right? Because we're focusing on x values along the x-axis. And if you look closely, well, what's happening with this negative 2? It corresponds with g of x having a y value of positive 2 and f of x having a y value of a negative 2, right? Negative 2. Positive 2, which is right there, right? Negative 2, which is right there. So, negative 2 on the x-axis corresponds with this special moment where the y value of f of x is the negative version of the y value of g of x. So the answer is negative 2, because that's the x value that corresponds with this special situation, right? So that's the answer. Hopefully that makes sense. Negative 2, we are done. And to be very clear, that corresponds with the x value that's associated with this interesting moment. Moving on. Okay. Questions 17 and 18 refer to the following information. Okay, the quantity of a product supplied and the quantity of a product demanded in an economic market are functions of the price of the product. Okay, so when they say that, don't get thrown off by that. That basically means that, the quantity of a product supplied and the quantity of a product demanded. Basically, the supply depends on the price. That's what they mean by that. The supply depends on the price, and also the demand depends on the price, okay? When they say that these two things are a function of price, it basically means that these two things, the blue and the green, depend on the price, which is sort of denoted here. This is probably the supply function, so the supply depends on whatever the price is. The demand depends on whatever the price is, right? Moving on, the functions above are the estimated supply and demand functions for a certain product. The function S of P gives the quantity of the product supplied. That's what I thought. They're using the S for supply, right? So I will write a green under supply. The price is $P. The function of D of P gives the quantity of the price demanded. Actually, I should do blue under supplied and green under demanded, because that's what I did before. By the market when the price is $P. Okay, great. Here they are. How will the quantity of the product supplied to the market change if the price of the product is increased by $10? Okay, so this is a moment where they're only really focusing on the the supplied function, which is the top function, right? That's the top function right here. We'll have blue for supply and green for demand. So for this problem, we only really need to focus on the top function. We could sort of ignore the bottom function. So how will the quantity of product supplied to the market change if the price of the products increase by $10? Well, one thing you can do is you can use your own numbers. I mean, that's one way to go. That's a very common way to go. So let's use our own numbers. That might be a good way to do this one to avoid confusion. And that's sort of a popular strategy for the SAT anyway. So before we begin, let's rewrite the function. And let's just say, okay, well, imagine that the price was, 10. Imagine the price was 10. We'll call it P1 for the first price that we're analyzing, P1. So basically that means that S of 10, which is P1, is equal to 1/2 of 10 plus 40, right? And we all know that that's going to be 5 plus 40, and that ends up equaling 45, right? So when the price is 10, the supply function churns out 45, right? When the price is 10, it's 45. So let's analyze what happens when we increase the price by 10 bucks, right? So now the new price, which we're going to call, do a little divider, the new price we're going to call P sub 2 is increased by $10, so the new price is 20. All right, so what happens when we put in 20? So it's going to be S of 20, and that's going to give us 1/2 of 20. I'll write that in a moment. 20, and what does that give us? Well, that's going to be 10, right? Because 1/2 of 20 is 10 plus 40, and that gives us 50, right? So, when the price is 20, it gives us this 50, correct? So we went from 45 to 50. That's what happened. When the price increased by 10 bucks, we went from 45 to 50. So that's an increase by 5 units. That's why answer choice A is the answer, okay? A decent problem to just plug in your own numbers, all right? There is another way of doing it that features like algebra and abstract, understanding the abstractions of the variables and so on. I think I'm going to stay away from that for now because I think most students would probably benefit from just bringing that problem down to earth by using real world numbers, okay? And then noticing the change that occurred. All right. At what price will the quantity of the product supplied to the market equal the quantity of the product demanded by the market, right? So once again, we're analyzing the product supply denoted by the function here, and we're analyzing the product demanded denoted by the function here, and we want to know at what price will the quantity of the product supplied equal the quantity of the product demanded. That's nothing more than setting this function equal to that function and then finding out what P would sort of cause these to be equal to each other. So we're going to set S of P equal to D of P. That's what we want to do. And just find out what value of P would cause these two functions to be equal. So S of P is, 1/2 P plus 40. And that equals 220 minus P, right? I'm going to stick with black as the ink to solve this. I don't like this 1/2. I'd rather just get rid of it. And the way that I'm going to do it is by multiplying the entire equation by 2. And when you do that, the 2 distributes here to the first term. It distributes to this term. It distributes here and it distributes there. Okay, so 2 times 1/2, p, is just p. In fact, that's the point of multiplying 2 times everything, is to cancel out, that denominator right there. You know what I mean? But 2 is still distributing everywhere else. So it becomes p, plus 80, because we don't want to forget to distribute it there. We don't want to forget to distribute it in these other places as well. So that's going to be 440. And don't forget to distribute the 2 here. That becomes negative 2p. Now, you don't have to do it that way, but I like to do it that way. So this was the original equation. That 1/2 is annoying to me, so I just would rather get rid of it right out the gate. Let's commit to having the p's on the left-hand side by adding 2p to both sides. That's going to give me 3p. All right, I'm not going to write that. I'm going to assume that my student at home understands if you add 2p to both sides, you're going to get 3p over here. And let's immediately subtract 80 from both sides. And that's going to give me 3p equals 360. And, dividing both sides by 3 would give me 120. That is the price that would cause these two functions to equal each other. That is the price that would cause the supply to perfectly equal the demand. Okay? So there it is, moving on. Okay, graphene, which is used in the manufacture of integrated circuits, is so thin that a sheet weighing 1 ounce can cover up to 7 football fields. That's actually amazing. If a football field has an area of approximately 1 1/3 acres, how many acres could 48 ounces of graphene cover? Let's see. Well, 7 football fields. So my thought is, they're basically saying that 1 ounce covers 7 football fields. And by the way, each football field has an area of 1 1/3 acres. Now, since the final question is asking how many acres, how many acres could 48 ounces of graphene cover, instead of thinking of area in terms of football fields, we're going to be better off thinking of area, the area that graphene can cover in terms of acres, because the final question is asking about acres. Acres as related to 48 ounces of graphene, right? So you can already see this is probably going to be a proportion, a nice problem to use a proportion at least. Whenever I do these proportions, I always like to get clear, the numerator represents something, right? And the denominator represents another thing, right? In this case, it's acres. And arrow. So we're going to set it up like that. Now apparently, we want to know how many acres could 48 ounces of graphene cover. So X, the X that's underneath this 48, that's the mystery. The amount of acres that is associated with 48 ounces of graphene, that's the mystery. So that's going to be X, right? But then we have to ask ourselves, well, what other pieces of information did the problem give us? Well, according to them, 1 ounce covers 7 football fields, right? So how many acres does 1 ounce cover, right? Because we can set this equal to 1 ounce over a certain amount of acres here, right? A certain amount of acres here. And then once we have this number, we could cross multiply and find X, right? So the question is, how many acres does 1 ounce cover? Well, it covers 7 football fields. Each football field is 1 1/3 acres. So if we want to find out how many acres 1 ounce covers, well, we multiply 1 1/3 acres times 7, right? So I'm going to do that sort of off to the side. So it's going to be 7 times 1 1/3. Now, you might want to change that into an improper fraction. So on the next line, we're going to rewrite 7, and we're going to change 1 1/3 to 4/3. And I got that by multiplying 3 times 1 and then adding 1 to get the numerator. And then we end up with the 3 down below. And then we have, this situation where we're multiplying a whole number times a fraction. Now, for those of you at home, in case you can't quite remember, there's secretly a 1 underneath that 7. So in a way, it's almost like multiplying a fraction times another fraction. Just multiply straight across. So we end up with 28/3. So that 28/3 goes right here, right? I'm going to put it in parentheses so as to make it abundantly clear that we have a fraction set equal to another fraction. It just so happens that this is the denominator right there, right? Now we're going to cross multiply, right? We're going to cross multiply, and I'll draw a little box around it to make it clear that this was sort of like a key that we could use as a reference for like what's happening here. We don't really need it anymore. We could just focus on this fraction equaling this fraction, which is a proportion. We're going to cross multiply, so that's going to be 48, times that fraction there. I'm going to worry about that in a little while. And that's going to equal 1 times x, which is just x. So really, this is the answer, right? Once we work this out, then we actually should have the answer. So 48 times 28/3, well, once again, you could think of 48 as a fraction with an invisible 1 underneath it, right? In the same way that we put a 1 underneath the 7. And there is a cross cancellation that could take place here before we multiply straight across. I'd rather not multiply 48 times 28 because that's a huge number. So, we could. We can use a calculator. But I would rather call this 16. We call that 1. So it's really 16 times 28. Okay, so it looks like we're going to have to use a calculator anyway. 16 times 28. But the good news is we have nothing but 1, 1 times 1 down below. So whatever 16 times 28 is, that's actually the answer. So I'm going to write on the next line, x equals, using the calculator, 16 times 28 is 448. That is the answer to the problem. Well, let's see. 450 is close, and it does say about how many acres, right? So 448 is not exactly the answer to the problem, but it does say about how many acres. So in case you get something close to the answer but not quite the answer, don't fear. It's possible that in the word problem they are asking you to estimate, and they are, because they're saying about how many. Well, about 450 acres is the answer. Moving on. Okay, chart thing. Michael swam, that's a scatter plot to be precise. Michael swam 2,000 yards on age of 18 days. Scatter plot above shows his swim time for and corresponding heart rate after each swim. The line of best fit for the data is shown. For the swim that took 34 minutes, Michael's actual heart rate was about how many beats per minute less than the rate predicted by the line of best fit? Okay, so first of all, for those of you watching at home, disregard this line for now and just know that the points that are plotted, these little dots or whatever, that actually represents the actual heart rate depending on the swimming time. So for example, for just under 36 minutes in swimming time, this person, Michael's heart rate was there, which is like, I don't know, looks like it's like 132, 4, 6, 8, like, maybe it's like 137 or something right there. Okay, so for 36 minutes of swimming time or just under, his heart rate was like around 137. All right, so these are the actual, these points are points that reflect the actual data from the study. Now, the line of best fit, for those of you at home, in case you're not sure, that is a line that statisticians and scientists and so on will use to get a general picture of what's happening with these points. Okay, now the line of best fit in a way helps you, among other things, make predictions, right? It helps you make predictions about the future. For example, for 38, it's safe to say that the heartbeat's going to be somewhere around here. For 39 minutes, it's safe to say that the heart rate is going to be around there, and so on, right? So anyway, focusing on the actual question, for the swim that took 34 minutes, so that's right here. That's the swim that took 34 minutes, which by the way is corresponding with this point, right? For the swim that took 34 minutes, Michael's actual heart rate was about how many beats per minute less than the rate predicted by the line of best fit. All right, so 34 minutes is right here. Here's his actual heart rate, and here's the line of best fit. So we're going to actually blow this up so we can see very close what's happening. So this is 34 minutes of swimming time corresponding with this point, and it is this discrepancy that they want to know, what is the difference between what actually happened and what was predicted. So in other words, what is this distance right here? Okay, now once again, in case you want to get clear on the wording of the problem says, for the swim that took 34 minutes, also known as this, Michael's actual heart rate, also known as the point, was about how many beats per minute less than the rate predicted by the line of best fit, also known as the line. How many beats per minute less? So what is the difference between the point and the line of best fit? Well, it is certainly the distance, or we could say the height of one of these boxes, right? Well, what is the height of one of these little boxes? Well, it depends on this. It goes from 140 to 50. How many boxes fit between 140 and 50? 1, 2, 3, 4, 5. And there's a difference of 10 units between 140 and 150, so each box has a height of 2. So that means, of course, that this is a 2 beats per minute discrepancy. 2 beats per minute, because that's the height of this box, right? That's the difference between these two. So many of you watching at home would probably experience me as overkilling the explanation here, but it's really the students that have maybe less experience with scatter plots and so on that I want to make sure all this is very clear. So the answer is 2, because it's 2 beats per minute less than the line of best fit. Okay, moving on. Of the following 4 types of saving accounts plans, which option would yield exponential growth of the money in the account? Well, each answer choice is describing what happens to each savings account. We want to know which one is describing exponential growth. I'm going to assume that that's exponential growth when contrasted against probably linear growth for a lot of these. So what is linear growth? Well, linear growth is when, for example, a linear function, here's an example of a linear function. Many students at home are used to it. And this is a line. If you graph that, it would be a line. And linear functions are such that it goes up by the same amount. For example, if x was years, we'll say S for savings, and we'll do 3 times t being time in years, Basically, every year that goes by, your savings go up 3, right? So it's this constant rate of change that goes up $3 per year, which is terrible. But I think the point of thinking in terms of linear functions is that you go up the same amount every year, whereas an exponential function might look something like this, where it's maybe you start with $10 and then you go up 10% per year, which by the way would look like this, because it's 1 times 10 plus 10% of 10. Okay, that's the way to think about it. But either way, don't get in the weeds with this. The bottom line is, every year that goes by, we're doing another 10% of the current value. So you have a current value, and then the next year that goes by, you do 10% of that value. And then the next year that goes by, you do 10% of the new value, and so on. And that's why exponential functions increase, they shoot upward at a certain point, where linear functions just go up at this slanted straight line, okay, at a constant rate, where linear functions go up at a constant rate, exponential functions start small and then shoot upward. Okay, so looking at answer choice A, Each successive year, 2% of the initial savings is added to the value of the account. So that's linear, because basically they're talking about 2% of the initial savings. Well, the initial savings maybe is $10. 2% of $10. Let's say the initial savings is $100. 2% of $100 is $2. So basically they're saying it goes up by $2 every year. It's like, no, that's linear. We are looking for exponential growth, not linear growth. We're not looking for a situation where we add $2 every year to our account. Each successive year, 1.5% of the initial savings and 100 is added to the value of the account. Well, once again, that's focusing on like the initial savings, and it's like 1.5% of that plus 100. Well, it's still the same amount every year. If the initial savings were $100, well, then it would be, $1.50 plus 100. So basically, according to answer choice B, every successive year, $101.50 is added to your account. Well, again, that is a constant rate of change, which therefore makes it a linear function. So that's gone. Each successive year, 1% of the current value is added. So that is exponential, because basically the current value, it's like, let's say we started with $100. Well, after the first year, we're going to have $101, right? And then after the first year, it's going to be 1% of $101. And then the next year is going to be 1% of that, right? So it's 1% of the current value. That's exponential. It's not 1% of the initial value. It's not 1% of the initial value, because the initial value is just the initial value. It stays the same, and therefore that would be a constant rate of change, whereas this is an exponential rate of change, because it's the current value, which changes literally every year. The current value changes and increases every year, so the 1% of the current value will increase it exponentially. So that's the answer there. Let's just take out answer choice D. Each successive year, 100 is added to the value. Well, that's a constant rate of change. Every successive year, $100 is added to the value of the account. That's literally, constant rate of change called $100 added to the, what's it called? The savings plan. So that's gone. That's linear. So that's gone. Moving on. The sum of three numbers is 855. One of the numbers, x, is 50% more than the sum of the other two numbers. What's the value of x? Well, you have a number a, you have a number b, and you're adding x. And you know that when you add them all together, it's 855, right? Now, according to them, x is 50% more than the sum of the other two numbers. So x equals, we can say the sum of the other two numbers, which is a plus b, plus 50%, which is 1/2 of the sum of the other two numbers. Now, I know that might be confusing, but when you hear that x is 50% more than the sum, well, that means x is equal to the sum itself. It's the same as the sum plus 50% of that sum. Okay, hopefully that makes sense. All right, x is equal to the sum of the other two plus 50% of the sum of the other two added on. Now, bottom line is, this has an invisible 1 hanging out in front. I'm just going to write it. And in a way, you could sort of combine these. This ends up becoming x equals 1 plus 1/2, which is 2/2 plus 1/2, which is 3/2. Okay. So that's the reality of what x equals. All right. Now, in case that's not clear, I kind of feel guilty just saying that. So let me just explain. This one is really 2/2. The a plus b is inside. And then we have this, 1/2 a plus b over here. Now I know a plus b is like, there's like a gobbledygook inside here. There's another thing, but notice this is literally the same as that. So this whole term is a like term. as this whole term, right? This might as well say 2 over 2 times w plus 1/2 times w. You could combine these, couldn't you? You could combine these. And what do you do when you combine like terms? Well, you keep the variable, in this case variables, and you add the coefficients, right? So we kept the a plus b, we kept the a plus b, and we added 2 over 2 plus 1/2, and we got 3/2. That's how I did it. Now, why did I do that? Well, at the end of the day, we want to solve for x, right? We know that a plus b plus x equals 855. Wouldn't it be nice to replace these a plus b things with like an x term? Well, we are, getting that much closer to doing so right now. Let's find out what a plus b equals. A plus b could be, let me just do a little divider here. So let's literally solve for a plus b. That way we could replace this a plus b with something else. So in order to solve for a plus b, well, we want to get a plus b by itself on the right-hand side of the equal sign. We're going to leave it over here on the right-hand side of the equal sign. So in order to do that, we have to ask ourselves, well, what's in the way of a plus b being by itself on the right-hand side of the equal sign? Clearly, this 3/2. So we have to find a way to get rid of that 3/2. Well, how are we going to do that? We're going to multiply both sides by the reciprocal of 3/2. We have to multiply both sides by the reciprocal. Now, why am I doing that? Because that 2 cancels with that 2, and this 3 will cancel with that 3. So this 3/2 is now gone. It's been completely canceled out by the a plus b, and that leaves us with a plus b by itself, and that equals 2/3 x, right? So now we know that a plus b equals 2/3 x, which means that this a plus b equals 2/3 x, right? So we're just going to write 2/3 x. Then we have plus x, and that equals 855. Okay, so we are very close to solving for x. Right now we have just these x things going on. My thought is let's get rid of the denominator of 3 because I do not like to work with denominators. I'm going to multiply literally both sides by 3. Now when I do that, this 3 distributes here and there. So when the 3 distributes here, it cancels that 3. In fact, that's the whole point of multiplying this side and this side by 3 is to get rid of that. So that leaves me with just the 2x up top, okay? In case that's not clear why. 3 times 2/3 x. Well, that's really 3 over 1, and the 3's cancel, leaving me with just this 2 over 1 times x, also known as 2x. That's why it's right here. So that's 2x, and then we have plus 3x. You do want to make sure that you are distributing the 3 there. Then we have equals, now of course, I should have written a 3 here. This 3 gets multiplied to the 855. Now 3 times 855 is, that is 2565, and combining like terms gives me 5x equals 2565. And using the calculator because I am allowed to do so, why not? That gives me, basically, dividing 2565 by 5 gives me 513. We are done. Yay, that's the answer. Moving on. Okay, the angles shown above are acute, and sine A equals cosine B. If A equals that, B equals that, what's the value of K? Okay, so there's a relationship where sine of some angle, if it's an acute angle, is equal to cosine of 90 minus that angle. That's worth noting. Now I'm using a theta symbol. You could call it sine x equals cosine of 90 minus x. That's fine, but this is a theta symbol. So, they then say, sine of A, according to this information, sine of A equals cosine of B. So, this is really that, right? Sine of some angle equals cosine of some other angle. Sine of some angle equals cosine of some other angle. So another way of saying, this is you could rewrite it such that it's sine of A equals, well, according to this, it's going to be cosine of 90 minus that same angle. So it's really, cosine of 90 minus A, right? The sine of some angle equals cosine of 90 minus that same angle. The sine of some angle equals cosine of 90 minus that same angle, right? So again, it all comes down to just understanding that this relationship is true. This relationship is worth memorizing again. So we can see here, it's like, okay, sine of A equals sine of A. Cosine of 90 minus A is really the same as cosine of B. So doesn't it therefore follow that 90 minus A must therefore be B, right? I mean, clearly we have cosine of some angle called B, and up here it says that 90 minus A is that angle, right? So you could really go off to the side actually and just write that 90 minus A equals B, right? Therefore, 90 equals A plus B, right? I mean, if you added A to both sides, it would be A plus B. 90 equals A plus B. Now, why the hell am I doing all this? You might be asking, why am I even doing all this? Well, because they're saying A equals 4K minus 22, B equals 6K minus 13. What the heck is the value of K? Well, I want to just get clear on, a good equation that features A and B. That way I could substitute 4K minus 22 and 6K minus 13 into that equation. Well, we set up a beautiful equation that features A and B by sort of remembering that this is true and then comparing this angle to that angle, which is right here. And then we have a nice equation that features A and B. So guess what we can do? We can substitute 4K minus 22 in for A, and we can substitute 6K minus 13 in for B, and then we will be on our way to solving for K, right? So A is 4K minus 22, and B is, we're adding B, 6K minus 13, and that all equals 90. Right, so A is right here, B is right there, and we're going to now solve for K right now by combining like terms first. The 4K and the 6K give me 10K, the negative 22 and the negative 13 give me negative 35, and we still have 90 over here. Obviously, it would be a good idea to get this 10K term by itself in order to solve for K. So we're going to add 35 to both sides. I'm just going to kind of do that right now. 10K, therefore, equals 90 plus 35 is 125. And then the final step would be to divide by 10, which gives me 12.5. I don't even need a calculator for that because dividing 125 by 10 is nothing more than moving the decimal place over once to the left. Therefore, answer C is the answer. There we go, moving on. Mr. Cole has a beaker containing n milliliters of solution to distribute to the students in his chemistry class. If he gives each student 3 milliliters of solution, he will have 5 milliliters left over. Okay, so he has a total of n, just based off of that information, he has a total of n milliliters of solution. And basically, if he gave each student 3 milliliters, he'd have 5 milliliters left over. So, again, n total milliliters, let's just say that, X equals amount of students in the class. So, according to this information, n milliliters of solution to distribute to the students in his chemistry class. He gives each student 3 milliliters, and then he has 5 left over. So once again, n represents how many milliliters of solution he has. So that's going to be 3 milliliters per student, and that still is such that there would be 5 milliliters left over. So that's the way to represent that first 2 sentences in an equation. The total milliliters he has is going to be 3 milliliters per student plus 5, left over. Okay, in order to give each student 4 milliliters, he will need an additional 21 milliliters. So in other words, if he had, n plus 21, if he had the same amount he had before, only he added 21 to it, then that would enable him to give 4 milliliters per student. 4 milliliters per student. Okay? So kind of a challenging problem. You have to be savvy with translating the information into these equations. Obviously, practice is helpful, right? But just know that I think the tip-off here was that he gives each student 3 milliliters of solution. He will have 5 milliliters left over. This is a classic case of 3 milliliters per student plus the remainder being over here. That's a way of thinking about equations that look like this sometimes, okay? And then from here it's like, okay, well, if you just added 21 to the n amount, well, then you'd finally be able to give 4 milliliters per student. So now we want to know how many students are in the class. Well, that's a matter of solving for x. This is a system of equations. This is already perfectly set up for substitution. N equals 3x plus 5. So I could replace this n with 3x plus 5. I'm going to do that right now because really we want to solve for x, right? We want to know how many students are in the class, also known as what is x, what is the amount of students. So replacing this n with 3x plus 5 would look something like the following, but I'm going to just write all this first. I'm going to write 3x plus 5 right now. And there's really an invisible 1 in front of here, so I could just drop the parentheses, to be perfectly honest. This is really just 3x plus 5 plus 21. 5 plus 21 is 26, so really we're dealing with 3x plus 26 equals 4x. Very easy to solve. All we have to do from here is just subtract 3x from both sides. That would give me x equals 26. We are done. That is the answer. Thank you, Lord. Moving on. All right, a grain silo is built from 2 right circular cones. There they are. And a right circular cylinder. There it is. With internal measurements represented by the figure above of the following, which is closest to the volume of the grain silo in cubic feet. All right, well, the volume, of this whole big thing, well, it's going to be the volume of the cylinder plus the volume of this cylinder, the cylinder plus the volume of this cone plus the volume of this cone. I'm really big on beginning with the end in mind and taking the view from 100,000 feet. And what I mean by that is I will set up the equation that I know is the actual answer. The actual answer is the volume of the cylinder, V sub CYL, plus the volume of this cone plus the volume of this cone. So that's really plus 2 times the volume of the cone, right? Just write that for cone, that for cylinder. So this is the answer. But the question is, what is the volume of the cylinder? And the question is, what is the volume of the cone? Well, the volume of any cylinder is given in the beginning of the SAT math section. I'm going to write down the formula in a moment. The volume of cones in general is given in the beginning of the SAT math section. They actually provide you with a reference guide that tells you this information. So the good news is you do not have to memorize the formula for the volume of a cylinder or the volume of a cone. It's given to you. You just have to remember that the formula for the volume of a cylinder and the volume of a cone is indeed there. You just have to remember that the SAT provides that, and then you would turn the page of the test booklet back to that section, and you would soon discover that the volume, we'll start with the volume of a cylinder, you would soon discover that the volume of a cylinder is, and I'll just write it here, CYL equals pi r squared times the height. And the volume of the cone really is the same thing, except there's a 1/3 in front of it. So it's like 1/3 pi r squared times height. So, really, this is, since it's the volume of a cylinder, it's going to be pi r squared times height plus 2 times the volume of the cone, which is 1/3 pi r squared times height. Now, we want to take into account the fact that this radius and this radius might be the same, but they also might be different. Well, actually, the radiuses are the same. Radii are the same. The heights are different, so I'm just going to be sort of precise. This is not necessarily too important, as long as you know that this height might be different than that height. But I like to be sort of precise, so I'm going to put a little 1 here, a little 2 there to denote the fact that this height's different than that height. So anyway, volume of the cylinder comes first. I'm going to go ahead and just write pi times something squared times something else, right? And the r is the first thing, right? So the radius is certainly 5 feet. That's the radius of the cylinder. And the height of the cylinder is clearly 10 feet. So 10 feet is going to go right there. And then we have plus 2 times, and again, I'm just going to do like empty parentheses for now. I like to just have these placeholders first and then take things from there. So 1/3 pi times something squared. Well, what's the radius of the cone? Because this is the volume of the cone. Well, that's 5 feet once again, right? And what is the height of the cone? Not the height of the cylinder, but the height of the cone, right? Well, that is 5 feet, and it's 5 feet down here as well, right? I felt comfortable saying 2 times the volume of the cone because I knew that this cone has the same cylinder and height. You could just kind of see it's 5 feet, 5 feet. So we're going to have 5 right there, right? And honestly, right now, this is the calculator section, so you could actually just plug this whole thing into your graphing calculator, including the pi stuff, because I don't see any pi's down here. So that means that you could either use 3.14 or actually use the pi symbol in your graphing calculator and just come up with a number. So I'm going to do that right now. Putting all of this into the calculator. And by the way, make sure that this is multiplication plus 2 times this whole product. This is a string of multiplication. It's really 2 times 1/3 times pi times 5 squared times 5, right? So it's a string of numbers being multiplied added to another string of numbers being multiplied. So just make sure that you're entering it into your calculator correctly. So as a result, we would get, like approximately 1047.17, which definitely corresponds with answer choice D. We are done. Moving on. In the xy plane, the line determined by the points 2, k and k, 32 pass through the origin. Which of the following could be the value of k? Okay, so we have really, in a way, the fact that they say that this line goes through not only these points but also the origin. That basically means that this line goes through 3 points. One of them is 2, k. Another point that this line passes through is k, 32. And another point that this line passes through is 0, 0. Now, I'm making a mental note of that because, it's going to be important to set up some kind of an equation, really, that would enable us to solve for k. Now, I can see that since the line passes through these 3 points, it should be the case that the slope between these 2 points is the same as the slope between these 2 points, and the slope between these 2 points is the same as those other 2 slopes as well. So in other words, the slope between any of these 2 points should be the same. Now I can foresee that calculating the slope between these 2 and then setting it equal to the slope between these 2 would totally work. All right, now you're going to see what I mean in a moment. Let's first remind ourselves of what the formula for the slope is. Okay, formula for slope is m equals y2 minus y1 all over x2 minus x1. So let's first calculate, or at least write down, the slope between these 2. Okay, so we'll call this x1, y1, and we'll call this x2, y2. So that would be 0 minus k all over 0 minus 2, right? And I'll actually write it on the next line. That ends up equaling k over 2. K over 2. Why? Because the zeros we can just disregard, and then we have a negative over a negative, which just becomes positive. So it just becomes k over 2. And what we're going to do is we're going to set that equal. We're going to set that equal to the slope between these. The slope between these. So this would be x1, y1. This will be x2, y2. So similarly, I'll write, 0 minus 32 all over 0 minus k. And what this turns into, it's really a negative 32 over a negative k, which is really going to be 32 over k, right? So this slope, which is right here, this slope equals this slope. So you have an equation, finally, that enables you to solve for k. And, of course, this is a proportion. You have a fraction set equal to another fraction. So you could cross-multiply. So that's what we're going to do. We are going to cross-multiply, and by doing so, we end up with k squared equals 64. And taking the square root of both sides would give me k equals plus minus 8, right? Once again, taking the square root here and taking the square root here, I have to do this plus minus thing. So square root of 64 is 8. It's going to be plus minus 8, so there it is, right? And that certainly gets us very close to the answer. What does it say? Which of the following could be the value of k? Well, 8 could be the value of k, because 8 is one of the potential answers to what k could be. Okay, so that's that one. Rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the triangle by 12%, what was the value of p? All right, so I'm going to imagine that we're dealing, like, the first rectangle is actually a square, because the square is a kind of rectangle. We're going to imagine that the length, the original length was 10. And I'll just call that L. And the original width was also 10. All right, and you're going to kind of see why I'm choosing these numbers. Now, I can make up these numbers because it's P, that's the constraint. We're trying to find P. So it's okay to make up your own numbers for the first triangle as long as you sort of stay very consistent with what they say in the word problem. So, the red rectangle slash square represents the original rectangle. And apparently after these alterations, the alterations decrease the area of this thing by 12%. So the area certainly used to be 100. But now we performed all these alterations. Maybe the new thing looks like this, right? And the new area, which I'll call area sub 2, so this is area sub 1, area sub 2, is this decreased by 12%. Well, 100 decreased by 12% is 88. So the new area is 88. And by the way, that's why I chose a 10 by 10 scenario, because I wanted to force that area of 100, because I knew that the new area decreased by 12%. That'd be an easy calculation, all right? So I am experienced, so I can kind of see that that would be helpful, all right? But nonetheless, the new area is 88. And, according to this, we increased the length by 10%. Well, what's 10% of 10? 10% of 10 is literally 1. So the new area is 11, or the new length is 11. In fact, I'll write the 11 down here, because this is, length 2, right? After the alteration, we'll call this length 1. And while we're at it, we'll call this W1. So according to them, we increased the length by 10%. Well, we just did it. 10% of 10 is 1, and we just increased it by 1 unit. So now it's 11. And, okay, right away, check this out. I could totally see that it's like 11 times this width should give me 88. So guess what? Right away, W, the new width, also known as W sub 2, is 8. There's no question about it. That's actually very nice to know. Because according to them, when it came to the red triangle, we decreased the red triangle's width by p%. And we want to find out what p is, right? So 8, is what we got after we decreased this width by 10. Maybe to avoid confusion, I'll write the width on the other side to kind of make it a little bit more similar to, this width is here, this width is there. So it went from 10 to 8. So after a p% decrease, we went from 10 to 8. Well, what is that? That's a difference of 2. So the question is, 2 is what percent of 10? Because, we decreased 10 by p%, which, by the way, ended up being 2. So what is p? In order to get from 10 to 8, we decreased it by 2. So in other words, the real question here is 2 is what percent of 10, right? That's the question. This is something that we can immediately translate into an equation. 2 is just 2. The word is equals. What percent? Well, you might want to call that x over 100. Just trust me on that. The word of means multiplication. So I'll do a little asterisk. And 10 is just 10. So fairly easy to work out in the sense that this 10, secretly has a 1 underneath it. We can do this cross cancellation with the 10 and the 100, where the 10 becomes a 1, and that becomes a 10. And then we end up with 2 equals just x over 10, because this is 1 over 1, so we can kind of disregard it because it's like times 1, so it's really just x over 10. So I'm going to do a little divider, and we are going to bring the situation over here. So we have 2 equals x over 10. We are trying to solve for x. We could do so by multiplying both sides by 10 to get rid of the denominator on the right hand side, and that is indeed what happens. So we have x equals 20. That is the answer because it's x percent. What percent? X percent, right? We knew it was a difference between 10 and 8. It was a difference of 2 between these two. According to them, it decreased by p%. So the real question is 2 is what percent of the original amount, which was 10, because it was the original amount that decreased by p% of itself, right? P% of itself, right? So that's how you would do that. X equals 20. That is the answer. Moving on. Okay, in planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. If the present population of the city is 50,000, which of the following expressions represents the engineer's estimate of population of the city T years from now? Okay, so basically, you start with a certain amount, let's say it's 50,000, and then every 20 years it goes down 10%, right? Every 20 years it goes down 10%. So I would bring this down to earth because to me, this could get a little confusing. So I would rather bring this problem down to earth by creating a table. And a table would be such that T is like the time in years, right? And then we have, population, so it's going to be P of T. Okay, so one thing's for sure, at T0, that is such that the population is going to be 50,000 because the present population is 50,000. So present population means time 0, right? Because it's T years from now. So like when T equals 1, that would be 1 year from now. When T equals 2, that would be 2 years from now. So as far as like right now in the present, when T equals 0, we know that the population is 50,000. So I'm going to go ahead and write 50,000 right there, because I know that's true. When t is 0, p of t is 50,000. Now we also know that the population of the city will decrease by 10% every 20 years. So I would go ahead and just take into account that when t equals 20, it's going to be 10% less than 50,000. Now, 10% of 50,000 is 5,000, right? So the population when t equals 20 is going to be 5,000 less than that, also known as 45,000. Okay, so that's what I would do for this problem, just to avoid confusion here. And I would literally find out, which of these answer choices are such that I could plug in these points and it would work, like they would both work. Now we could start with the top. We could start with 0, 50,000. Is it the case that when t is 0, this equals 50,000? Well, yes, because it would be 20 times 0 here, which would turn that 0.1 into a 1, and then it would be 50,000. So A is a contender with regards to the first row. So we're going to analyze the first point in the first row, which is 0, 50,000. So when t is 0, this is 50,000. So that's a possibility. For the same reason, this would work as well, because when that t is 0, then this whole fraction would be 0, because it'd be 0 over 20, which would make the 0.1 turn that into a 1, which is 1 times 50,000, which is 50,000. So when it comes to this one, it is the case that when t is 0, the whole thing equals 50,000. This one here, for the exact same reasons, 20 times 0, this would be 50,000. So actually this one will work too. So all these work with regards to this first point. So the first point doesn't really help us too much. Let's take a look at the second point. What happens when t is 20? Does the whole thing turn into 45,000 when t is 20? Well, this would be 20 times 20 up here, which is 400. So therefore you'd have 5,000 times, or 50,000 times 0.1 raised to the 400 power. That would not equal 45,000. In fact, I'm going to sort of figure out what that is. It would be 50,000. I'm going to literally plug it into my calculator right now. I'm going to use parentheses around that 0.1, and I'm going to raise that 0.1 to the 400 power. Yeah, that pumps out a 0 in my calculator right now. I'm using Desmos. And it makes sense because basically it would be sort of like infinitely small if you raise 0.1 to the 400. That would make a very tiny fraction here. And then when you multiply that times 50,000, you're effectively at 0. So Desmos actually can't handle how small that number would be. And make sure we're clear that we are looking at this one right now. All right. So this is gone. A is gone because when t is 20, this whole thing does not equal 45,000. This whole thing equals 0. When t is 20 here, well, that would be 20 over 20, which is just 1. So it would be 0.1 to the first power, which is just 0.1. And then 0.1 times 50,000 is way less than 45,000. Way less than 45,000. In fact, I'm going to multiply it right now. 50,000 times 0.1. That's 5,000. In fact, we kind of calculated that when we subtracted it from here. But we want 45,000. We don't want 5,000. So basically, when t is 20 here, this whole thing turns into 5,000 when what we're looking for is 45,000. So that's gone. Okay, when t is 20 here, that's going to be 0.9 raised to the 400. So let me actually try that. 0.9 raised to the 400 power. And I'm going to, that's a crazy number. And I'm going to multiply that times 50,000. And that gives me another crazy number. So this is gone as well, leaving by process of elimination answer choice D as the only one that would work. And by the way, it makes sense that this would work because when t is 20, it'd be 20 over 20, which is just 1. So really it'd be 0.9 raised to the first power, which is just 0.9. And then 0.9 times 50,000 is 45,000. That's essentially saying, 0.9 is really, what's 90%? Well, 90% of 50,000 is 45,000. What is 90% of 50,000? Well, that's 50,000 minus 10% of itself, right? Which is essentially what we're looking for because according to the problem, the population of the city will decrease by 10% every 20 years. Therefore, at year 20, it should be 45,000. Okay, so I would bring this one down to earth. I would use the 2 key points. Find out what happens when t is 0, find out what happens when t is 20, and then you would see that it would be 45,000, and then just check each point and make sure, you're eliminating the ones that do not work. All right, and process elimination is your friend. We will move on. Okay. The incomplete table above summarizes the number of left-hand students and right-hand students by gender for the 8th grade students, right? So it's incomplete, okay. There are 5 times as many right-handed female students as there are left-handed female students. So the females are here. So, based off of that info, I think I'm just going to fill in the table right now because it's incomplete, so you might as well just fill it in. There are 5 times as many right-handed female students as left-handed female students. So that means you have a certain amount of left-handed female students. We're going to call it X. And according to the problem, there are 5 times as many right-handed students, female students. So that goes there. All right. This is all based off of this sentence right here, at least this part of the sentence, right? There are 5 times as many right-handed female students as there are left-handed. So even though they mention the right-handed students, you want to assign X to the other thing, the left-handed students, and then just go 5X over there, all right? They also say there are 9 times as many right-handed male students as there are left-handed male students. So I'll sort of underline that information in blue. And you want to be careful. You don't want to call it X over here because it's not necessarily true that this number is the same as this number. So I'm comfortable calling that Y, and we could call this 9Y, right? Y and 9Y, because there are 9 times as many right-handed male students as there are left-handed male students. Well, there it is. If there are a total of 18 left-handed students, well, they gave us that. And there's a total of 122 right-handed students. Well, they gave us that as well. In the school, which of the following is closest to the probability that a right-handed student selected at random is female? So they're pulling from the right-handed students. So they're pulling from this column, right? They want to know what's the probability that a right-handed student selected at random is female. Note, assume that none of the 8th grade students are both right-handed or left-handed. Okay, well, yeah, obviously. So, let's see. Well, it's definitely going to be, probability in general, as I've mentioned before, is always going to be the want over the possible. And what do I mean by that? I mean, the numerator is going to feature the sort of target that you're going for, whatever that number is, like how many of the things that you're looking for are, and that goes there. And this denominator is all the possible things that could happen, right? Now, since we're choosing and we're pulling from the right-handed people, clearly the probability will have a denominator of 122, right? Because that's how many right-handed people there are in this whole group. And again, it says, which of the following is closest to the probability that a right-handed student selected? So we're selecting from right-handed students. So there's 122 possibilities, which goes here at random as female. So we want to know, the probability that we have a female pulled from this. Well, the desired or the wanted in this case is certainly going to be the 5x, right? Now, we could totally solve this. We could figure out what this is, divide it by 122, and then, figure out which answer choice matches what we got. The problem is we don't know what x is. I mean, if we knew what x was, we'd totally be able to solve this. So just know that this is the answer, but we have a submission of finding out what x is. So we're going to do that right now. Now, the way that we could do that is we could recognize that there is a system of equations being formed here, and it's good that we filled in the table. In fact, they left it blank for a reason. They left it blank so that you would fill it in. And one thing you know for sure is that x plus y equals 18, and 5x plus 9y equals 122. So you could totally set that up where it's like x plus y equals 18, and 5x plus 9y equals 122. Now, at the end of the day, we want to find out what x is. We're not terribly interested in what y is. We want to find out what x is, because once we find out what x is, we can plug it in here. So whenever you're going to use substitution, which, by the way, I think is a good idea. If we're going to solve this system of equations, we should use substitution. If you're going to do that, and you want to solve for x, you actually want to use this one and solve for y first, ironically. It's almost like the opposite of what you would think. And this becomes y equals 18 minus x. And then you take that thing and plug it in for y here, and then you're home free. All right, so let's just do it right now. We're going to have 5x plus 9, not times y, but times 18 minus x. All right, 18 minus x equals 122. Obviously, from here, it's going to be 5x plus 9 times 18 is 162. And by the way, I'm distributing. That's what I'm doing right now. And then we have 9 times negative x, which is negative 9x. That equals 122. And from there, 5x combines with that negative 9x, giving us negative 4x. Let's go ahead and also, while we're at it, just subtract 162 from both sides. So that is going to be negative 4x equals negative 40, which, by the way, I think is a good sign. The fact that we have a number that's divisible by negative 4, right? So when we divide both sides by negative 4, of course, we are going to get 10, which is a positive number, also a good sign, right? We want positive numbers because there's a positive number of female students. So we have 5 times 10 over here. We'll just bring that over here. So that equals 50 over 122. So that's actually the answer. That is the answer to the problem, little divider right here. But the question is, what is 50 over 122 in terms of a decimal? So all you have to do to figure that out is, in your calculator, just go 50 divided by 122. Every fraction is secretly a division problem, so 50 divided by 122. And that would be, let's see, 0.4, it's really 0.409, which rounds up to that. And that corresponds with answer choice A. Hopefully that makes sense. Pause, rewind if need be. Moving on for now. Okay, and the equations above, B and C are constants. If B is C minus 1/2. All right, so as soon as they say that, I'm just like, all right, B equals C minus 1/2. All right, which of the following must be true? X is Y. All right, well, let's see. X equals Y minus 1/4. Well, let's think about this. I mean, when you look at the answer choices, you see that these are all kind of like equations, even though they don't look like it. So, in other words, let's just analyze this part, and you're going to see why in a moment. But for example, answer choice A is really saying x equals y minus 1/4. Answer choice B is secretly saying x equals y minus 1/2. And, answer choice C is saying x equals y minus 1. And answer choice D is saying x equals y plus 1/2. So don't get thrown off by the fact that there are words being used. I mean, these are all equations. And, it'd be nice to know the answer to, how does x relate to y? I mean, essentially, these are all equations that tell you how x relates to y. But the problem is we don't know because we have these darn b and c's in the way. But the fact that they told us this, that's our ticket to getting rid of the b and c's, actually, so that we can only have an equation that features x and y. So we'll see how that works now. So basically, I'm going to write the top equation, which is 3x. But instead of writing b, I'm actually going to write c minus 1/2. And that equals 5x minus 7. And now I'm going to write the bottom equation, but I'm not going to change anything about it. I actually want it to feature that c right there, because I'm setting things up so that I could do elimination. All right? So that bottom equation is 3y plus c equals 5y minus 7. So these are the two new equations that I'm going to be focusing on right now. Now, what can I do with these? Well, I'd love to eliminate the c's, right? Now we don't have to worry about b anymore. All we have to do is eliminate the c's. Once we eliminate the c variable, then we'll have nothing but x and y variables, and then we could find out how x and y relate to each other and then figure out which one of these equations is correct. All right? So basically, let's see. To avoid confusion, I'm going to rewrite these so that all the variables are on the left and we have nothing but a number or numbers on the right. Right, because that's kind of how most people are used to doing systems of equations anyway. So when I do that, this one over here really just becomes, if I want to get all the x's on the same side, I would have to subtract this 5x from both sides, so that's going to become negative 2x, and we're going to have plus c, and actually I'm going to commit to having the constants on the right hand side, so if I add 1/2 to both sides, I'm going to have positive, or I should say negative 6.5. Okay, so if I treated this negative 1/2 as a negative 0.5, and then I added 0.5 to both sides, well, positive 0.5 plus this negative 7 is negative 6.5. And when it comes to this other one, I'm committing to stacking at least the c over the c for sure. Let's get all the y's on the left-hand side. So I would do so by subtracting, 5y from both sides. And that would end up giving me, I'll keep this in red as well. So that's going to be negative 2y plus c, and that equals negative 7. So my goal is to get rid of these two c's. I have a negative 2x plus c equals negative 6.5. I have a negative 2y plus c equals negative 7. My goal is to get rid of these c's. Now, this is a positive c, this is a positive c, so it'd be nice to turn this one into a negative c. And I could do that by, of course, multiplying, the entire equation right here by a negative 1. And that negative 1 would distribute everywhere, right? It would distribute everywhere, and that therefore becomes the following equation. It would end up becoming positive 2y minus c equals positive 7. So really, the equations that I'd like to work with are this top one right here and this one right here. So we're very close to figuring out the answer. All you have to do now is work with this one. And this one, negative 2x plus 2y is going to be negative 2x plus 2y. These c's are going to cancel. And then negative 6.5 plus 7 is going to be 0.5. So at the end of the day, after adding those equations, you're going to have negative 2x plus 2y. There aren't going to be any c's because they canceled out, and you're going to have negative 0.5, also known as 1/2. Now, each of these answer choices feature x by itself, so let's get x by itself. We could do that by subtracting 2y from both sides, and we would end up with negative 2x equals, negative 2y plus 1/2, 0.5. I'm going to call it 1/2 for now because I see a bunch of fractions like 1/2 and 1/4, so that makes me think that maybe I might want to turn this decimal into a 1/2 now. And from there, we would want to get x by itself because all the x's over here are by themselves. So let's divide everything by negative 2, and that's going to give us x equals positive y because those negative 2's cancel out, minus 1/4 because positive 1/2 divided by negative 2 is negative 1/4. So in case that's not clear, I'll kind of do that right now. 1/2 divided by negative 2. Well, that's really 1/2 divided by negative 2 over 1. And as you might recall from back in the day, when you're dividing fractions, you keep the first fraction, 1/2. You change it to multiplication, and you multiply by the reciprocal. Now you might be asking, well, what about the negative? Is the negative assigned to the 2, or is the negative assigned to the 1? Actually, it doesn't matter. The negative is assigned to one or the other, but not both. That's what you need to keep in mind. You could think of it as assigned to the 2 and not the 1, or you could think of that negative as assigned to the 1 and not the 2, just to clear that up. And as I said before, multiplying fractions is pretty easy. Just go straight across. That's going to be negative 1 over 4. So that's, how I got this negative 1/4. Okay, I divided this 1/2 by this negative 2. All right, and that's the answer. That's the answer. So where do we find this? We find it here. It's literally the first one. All right, x equals y minus 1/4. We sort of took this, we got rid of the c. They gave us a clue as to how to get rid of the b. They told us the b equals c minus 1/2. So we replaced this b with c minus 1/2 over here. And then we just restructured these so that you had, variable over variable, c over c, constant over constant. And then I just subtracted the bottom from the top, in order to get that negative, c. Basically, we could think of multiplying the bottom times negative 1 to get this, and then I, in a way, just combine these, right? And I ended up with x equals y minus 1/4, and there we are. All right, kind of a tricky one, but that's how you do it. Tickets for a school talent show cost $2 for students, $3 for adults. If Chris spends at least $11 but no more than $14 on X student tickets and one adult ticket, what is one possible value for X? All right, so he spends at least $11 but no more than $14. I'm going to choose 11. All right, so apparently I'm going to call it 11 since it could be at least 11, so that means it could be 11. So we're going to choose 11 as the number that he spent just to avoid complication. And X student tickets and one adult ticket. So he actually bought only one adult ticket, which is $3. So we know it's going to be $3 plus X times, X student tickets times $2. It's $2 per student ticket, so it's really 2X, right? 2X plus 3, and then that ends up being $11. It's really just simple as that. It's about not getting intimidated by any of this stuff. Noticing that they have a nice constraint for us. They literally tell you that he spent, he bought one adult ticket. Well, that's right here. It's $3, right? $2 per student. X student showed up, so that's going to be 2 times X, and that equals 11. We chose 11. We could have chose 12. We could have chose 13. We could have chose 14, actually. We couldn't have chosen 15, though, because it's got to be no more than 14 and so on, right? So 11, 12, 13, 14, all of that would work as a number here, right? Although I'm seeing that actually even numbers would not work, because whatever 2x plus 3 is, it must be odd. The reason for that is because you have an even number here, because 2 times anything is an even number, plus 3. That's going to result in an odd number. So actually 12 and 14 would not work. So in a way, I got lucky by choosing 11. 11 and 13 would work. All right. So nonetheless, here we go. Subtracting 3 from both sides gives me 8. Divided by 2 gives me 4. So it's possible that 4 students showed up for this talent show. All right, so that's how that works. The SAT would most definitely accept that as an answer. Had you filled this in with 13, then it would have worked as well. X would have been 5, so 4 or 5 would have worked. Nothing else would have worked, because had you chosen 12 or something, X would be 4.5, and that makes no sense, because how could you buy 4.5 student tickets, right? So only an odd number would work here. In other words, only 11 or 13. Once again, I'll say it. The reason why it has to be odd is because this term itself has to be even, because 2 times anything is an even number. And an even number plus an odd number always gives you an odd number. An even number plus an odd number always gives you an odd number, not an even number. All right, so hopefully that makes sense. Ages of the first 12 United States presidents at the beginning of their terms in office. Cool. Yay. Table above lists the ages of the first 12 when they began their terms in office. According to the table, what was the mean age in years of the presidents at the beginning of their terms? That's super easy. You just add it all. The mean, right? Mean. There it is. Where's that word? The mean age, right? What's the average? So that means the average. So you just average all this, right? How many are there? There's 12, right? So it's going to be the sum of all this stuff divided by 12. I'm going to do it right now on my calculator. I'm going to add all these numbers, and then I'm going to divide by 12. And that would be, when I added them, it became 580, just so you know. And then when I divided that by 12, 12 people, that's 48.3 repeating. Okay. So they say round your answer to the nearest tenth. So actually you are going to want to grid in 48.3 because that is rounded to the nearest tenth. You want to do exactly what they say when you're gridding in the answer. They tell you round it to the nearest tenth. You want to do exactly that. So there you go. If the expression above is rewritten in the form ax squared plus bx plus c, where a plus and b are constant, what's the value of b? So we want to force this to kind of look like that, essentially. That's essentially what's happening here. So the way that we do that is recognize that at the end of the day, there's secretly a 1 that's like in front of that gets distributed. So all that happens there is we drop the parentheses and everything else stays the same because 1 times anything is just itself. So this is just a way of distributing a positive 1 into the parentheses, dropping the parentheses. But this is another story. This -2 actually, distributes in and changes the sign, among other things, when you distribute it. So let's focus on the yellow part. So after that, we end up with -3x squared plus 5x minus 2. And then the blue part says that we have to call it -2x squared plus 4x plus 2. That's a like term, that's a like term, that's a like term, that's a like term. Combining like terms, I'll do it all in black, gives me x squared. The 5x plus 4x gives me a positive 9x. And guess what? I do not even care what the constants are. This is b, right? Because b is the coefficient of the x term. This is the coefficient of the x term because I just combined them. It's 9, therefore the answer is 9. Saving time, moving on. In a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by the central angle is what fraction of the area of the circle? Well, okay, sector. What is a sector? Sector is when you have a circle and the sector is basically this pizza pie slice right here. Notice how it's a piece of the whole area, right? This sector area is a part of the whole area. And in fact, there is sort of a formula that you can use that's definitely important to know for the SAT that says sector area over the whole area of the circle. Well, that's going to equal the central angle over the whole angle. Now, it looks like this is in radians. We want to be careful. This is in radians. Now, the entire, rotation around the circle, if it was in degrees, it would be 360 degrees. But since it's in radians, you do need to know that it's 2 pi radians. 2 pi radians is the equivalent of 360 degrees. So it's the central angle, meaning, this angle, over the whole rotation all the way around, over the whole rotation all the way around, also known as 2 pi. So that's important to know. So the central angle has a measure of 5 pi over 4. The area of the sector is what fraction of the area of the circle. So in other words, this part right here, let's read it again. The area of the sector formed by the central angle AOB, which is like that, is what fraction of the area of the whole circle? in other words, they're asking, what is this fraction, right? They're saying the area of the sector, also known as this, is what fraction of the area of the whole circle, also known as the whole area right here. Well, we know from this formula that sector area over the whole area of the circle equals the central angle over 2 pi. So really, what we could do is, if we just found the central angle over 2 pi, well, that would be the answer, because this equals that, right? So our goal is to just find this. And the reason why I want to focus here is because they give us the central angle right here, right? It's right there, 5 pi over 4. So this is going to be as follows. This is going to be, I'll write it underneath in black, it's going to be 5 pi over 4. That's the central angle over 2 pi. And this is going to be the answer. Okay? Now, the question is, how do I navigate this? 5 pi over 4 over 2 pi. How do I simplify that? Well, one way of simplifying it is to realize that every fraction is secretly a division problem. So you have some number divided by another number. You have 5 pi over 4 divided by 2 pi. So I'm going to go ahead and rewrite that as this, 5 pi over 4 divided by 2 pi. Now, what is 2 pi? Well, secretly there's a 1 under there, so I could draw an invisible 1 under there. So in a way, it's really a fraction divided by another fraction. You could think of it that way, right? You could totally think of it that way. Now, what do we do when we divide fractions? Well, we did this recently. You keep the first thing, you change it to multiplication, and then you flip the second thing. Now, when we do that, it so happens that we have some lovely cancellations. The pi's cancels, right? These cancel. And nothing else. 5 does not cancel with 2. 5 does not cancel with 4. 1 does not cancel with 4. So we're stuck with the rest of it. So 5 times 1 is just 5. And 4 times 2 is just 8. And that is the answer, because once again they asked, the sector formed by the central angle is what fraction of the area of the circle. In other words, what is this fraction? Well, this fraction equals this, according to the sector area formula. And so therefore we could just find this, and that would be the answer, because these two equal each other. Well, we did that. We stuck the central angle, which is 5 pi over 4 up top. We have our 2 pi down below, which, by the way, is always there if you're in radians. And then we just kind of worked it out, simplified it, and we realized that it was 5/8. 5/8 is something you can certainly grid in to the SAT by writing, 5/8. You could also turn that into a decimal and put the decimal in as well. Okay, but you might want to stick with just a fraction because it's easy, right? And there's that slash symbol in the grid in response answer key. All right, or answer sheet, I should say. All right, moving on to the next. An online store receives customer satisfaction ratings between 0 and 100 inclusive. Inclusive means 0 is a possibility and 100 is a possibility as well. In the first 10 ratings, the store received the average arithmetic mean of the ratings was 75. What is the least value the store can receive for the 11th rating and still be able to have an average of at least 85 for the first 20 ratings? All right, so basically we're going to have to use the average formula. Now the average formula is this. Average equals sum of terms all over the number of terms. So we know for sure that we're shooting for an average of at least 85, right? And we're also sort of asking ourselves, what is the least value the store can get for the 11th rating? There's going to be 20 total ratings and still be able to get an average of at least 85. So if we're going to analyze the least value necessary for the 11th rating to get at least 85? Well, we want to minimize this value, right? We're looking for the least value that the 11th rating could be, which means we're trying to minimize that number. We're trying to find out how small we can make this number. And in order to do so, we want to have the least possible value for the total average, which is 85. So we want to set up the formula so that the average is 85, right? Because that's the smallest average we could have, because it has to be at least 85. That's the smallest average it could have. And that way we can really figure out just like exactly how small we can make that least value, given all these parameters and so on. So what I would do is sort of get the big picture. I mean, the average that we're shooting for is at least 85, which is 85 in this case. We have 20 total ratings, so you start to piece together this average formula. Now, what's going to be up here? It's going to be the sum of literally all 20 ratings, right? Well, it's going to be the sum of the first, we could say 10 ratings, right? First 10 ratings. And then you're going to have the 11th rating, right? So imagine, I'll even draw these little, circles. Don't take these too seriously. These are not zeros. These are just the ratings. There's 10 of them. And then there's the 11th one, right? We're going to call that X. That's the 11th rating. 11th. And then you have the remaining 9 ratings. The remaining 9 ratings over here, right? And I'm literally going to blow this up and call them the remaining 9. Okay, remaining. And the reason why I'm doing this is because I want to get a big picture view of what's going on. It seems that using the average formula would be helpful here. We're going to have the first 10 plus the 11th plus the remaining 9. I mean, we could even fill in just a couple things over here to denote that there are, there's 9 things being added together. This is the 11th one that's being added. These are the first 10 that are being added. And anyway, let's see. With regards to the first 10, we can get a sense of what they add up to, at least. We're not going to get a sense of what each rating is, but we can get a sense of what they add up to. And how could we do that? Well, we could do that because they gave us this clue. In the first 10 ratings the store received, the average was 75. So what that means is, as it pertains to the first 10, here's the average formula. As it pertains to the first 10, the average was 75. We had divided by 10 in order to get that. And then we just say sum of first 10, right? Sum of first 10. So again, we're not going to be able to find out what each rating is, but we can certainly find out what the sum of the first 10 is. And the way that you could do that is, of course, by multiplying both sides of the equation by 10. And that would cancel out that 10 that's in the denominator. And that cancels with that. And therefore, you end up with a situation. I'll do a little divider. You end up with the following situation, where you have 7,500, or 750, I should say, equals the sum of the first 10. I'll just call it first 10. So it is the case that the sum of the first 10 equals 750. How did we know? We used the average formula. They told us that the average of the first 10 was 75. So we use the average formula here in red to find out what the sum of the first 10 ratings is, and that is 75, right? So that means that this sum of the first 10, I should say 750, is 750. So we could sort of rewrite this formula so it reflects that 85 equals 750 plus the x that we're looking for, And I'll just write it out this time. This is very small writing, so just know that it's going to be plus the remaining 9. I'll just write it in parentheses. The sum of the remaining 9. Remaining 9. And that's going to be all over 20. So this right here is nothing more than this rewritten, only now we know the sum of the first 10 is 750. The 11th term is still x. In fact, that's kind of what we're trying to figure out in the problem, what the 11th term could be, like the smallest number that the 11th term could be. And then we have the sum of the remaining 9 over here. Well, one thing you could do from here is you could kind of do something similar where you multiply both sides by 20, and then we'll have like a one-story equation at our disposal, similar to what we did here. We multiply both sides by 10, and that knocked out the denominator. And we could do that here. So we're going to multiply both sides by 20. And as you will see, what this does is it knocks out that denominator because that and that cancel. We still have the 20 and the 85. So 20 times 85 is 1,700. And that would equal 750 plus x plus the sum of the remaining 9. So we have this scenario right now. Once again, we're trying to find the least value of x that we could possibly have, the least value of the 11th term that would give us at least an average of 85. So we're forcing the average to be 85. We're setting up the average equation. And now we're just kind of getting a little bit closer to understanding what x could be as far as the least value that x could be. That's the goal, just kind of reminding you of what we're doing here, because there's a lot going on, obviously, in this problem. So what we could do now to get even closer view of what x could be, let's subtract 750 from both sides. And in doing so, 1,700 minus 750 is 950. And that's what you get when you have x plus the sum of remaining 9. Right? So once again, we're trying to find out the smallest number that x could be given all these constraints. Okay? Now, here's the deal. We have x plus some whole number when you add all the 9, up, the remaining 9 up, right? In order to make this as small as it could possibly be, if you think about it, it makes total sense to therefore make this as large as it could possibly be. We want the sum of the remaining 9 to be as big as I should say. The sum of the remaining 9 should be as big as it could possibly be, right? So how big can we make the sum of the remaining 9? Well, let's take a look. According to the problem, let's see. Customer online store receives customer satisfaction ratings between 0 and 100 inclusive. So the highest score that you could get is 100. So let's imagine a scenario where the sum of the remaining 9 is such that each of the remaining 9 is a score of 100, and therefore it would be, the sum of that would be 100 times 9, and therefore 900. So we could rewrite the equation with the intention of minimizing, x by maximizing the sum of the remaining 9 and assuming that each of these ratings was 100, and 100 times 9 ratings is 900, a sum of 900 points. And we have officially maximized the sum of the remaining 9 by calling it 900. And in order to solve for x, all we have to do is obviously subtract, 900 from both sides. And that gives us 50, which is the answer. So in other words, the smallest rating that the 11th term could be, out of all these 20 terms, while still getting an average of 85, is 50. If this 11th term was smaller than 50, then it would force this 85 to be a little bit less, right? So we minimize the average because it has to be at least, 85. So we minimize that by making it literally 85. We took into account that we're averaging 20 total scores. The first 10 plus the 11th plus the remaining 9. The first 10, we didn't know which each individual score was, but we figured out that the sum of the first 10 was certainly 750, and we used the average formula in order to figure that out, right? So we knew that the first 10 added up to 750, plus the 11th, plus the sum of the remaining 9. We then knocked out the 20, giving us 1700 in this. We then, realized that we could get a better picture of what the 11th term is if we got rid of this 750. We subtracted that from both sides. We ended up with this. We realized that in order to minimize this term, we have to maximize this term, which turns it into 900. And then we subtracted 900 from both sides, giving us x equals 50, which is the answer. Okay, in the xy plane, if a point with coordinates a, comma, b lies on the solution set of the system of inequalities above, what is the maximum possible value of b? Right, so AB lies in the solution set. So this is inequalities, which is sort of like similar to graphing lines, only this is the thing where you have to shade the regions of the xy coordinate plane. I think in order to solve this, recognizing that AB lies in the double shaded region, and we want to know the maximum possible value of B. In other words, what's the maximum y coordinate that exists inside the shaded region? I would much rather get a sense of what the shaded region actually looks like by doing a rudimentary graph here. Okay, so let's see. XY coordinate plane, right? Just a rudimentary graph. I see a Y-intercept of 3,000, which is pretty big, right? So, we'll make this 3,000. Why not? And according to the top equation, it's negative 15x plus 3,000. So the slope is negative 15 over 1. So that's kind of like a steep slope downwards. I'm just going to represent that. Now, before I draw it, let's keep in mind there is an underline underneath the inequality symbol, which means that I'm not going to draw a dotted line, but I'm going to draw a solid line when I do this. So here is a pretty steep, line that goes down like that. So it is the case that y is less than or equal to all this, which basically means that I want to shade whenever y is less than or equal to the rest of it, then you want to shade below the line that you just drew. So I'm going to use the marker and just kind of shade below, right? All that. So the shaded region here is literally the solution set of the top inequality. So we're going to graph the bottom inequality. Y is less than or equal to 5x. So you temporarily treat that like a normal old line. That's a pretty steep slope upward of 5 over 1. The y-intercept is 0, so this thing, comes out of the origin, and it just kind of shoots up like that, Now, kind of goes on forever downward too, but you can imagine it goes through the origin there. And once again, we are shading everything below the rest of the inequality, so we're shading everything below the line. So that's going to be this, shaded region, everything below that line, right? But here's the deal. This is a system this is a system of inequalities, which means that the solution set to the system of inequalities is the double shaded region. So the double shaded region is clearly right here. It's this triangular shape. Now, according to the problem, a comma b, some point called AB, lies inside this triangle because it lies in the solution set of the system of inequalities. What's the maximum possible value of b? In other words, what's the maximum y-coordinate that could take place in this double shaded region? Well, clearly it's right there. That's the highest point, right? The maximum possible value of b, which is the y-coordinate, the maximum possible value of a y-coordinate is literally the highest point in that solution set, and the highest point is clearly at the tip of the triangle right there. So let's mark that, right? So the question is, how could we find that? How could we find that? Well, it's actually very easy. All you have to do is treat these as though they're equations, and find out the y value where this equals that, right? Because there's this moment where this line has the exact same y value as this line, and we could find out what the x coordinate is in that moment by setting this equal to that. All right, so we are going to set negative 15x plus 3,000 equal to 5x. And this will enable us to at least find the x-coordinate that is associated with this y-coordinate. In other words, it would enable us to find a, right? But we're going to keep it in, we're going to leave it as x. So let's see. We could add 15 to both sides. I like keeping the x term positive, so I'm going to add 15 to both sides. That's going to give me 20x equals 3,000. Dividing both sides by 20 gives me 150. Now, in order for me to know what b is, we just discovered what a is essentially. It's 150. And in order for us to know what b is, all we have to do is just pick one of these and plug in 150 for x. So I'm going to choose this bottom one because the bottom one looks great. And we're going to turn it into an equation because we actually want to know, what does y equal when x is 150? What does y equal when x is 150? So we're going to set y equal to 5 times 150, and that's going to give us the answer. Y therefore equals 750. So that, my friends, is the answer. We could say b equals 750. Now, another way I could have, drawn it is I could have recognized that the x value such that, this inequality equals this inequality is really a, right? At least according to them, a. So I could have, written this as negative 15a plus 3,000 equals 5a. And then I would have realized that a equals 150, and then I could realize that, in order to find b, I could set it up such that b equals 5 times 150. So I could have been a little bit more precise, I suppose, with the variables and so on, but it's really the process that's important and the logic behind it that's important for you guys to know. All right, so 750 is the answer. That is something that you could grid in, obviously. All right, so these are the final two questions. Let's take a look. If shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time of T minutes, the average number of shoppers in the store, also known as N, at any one time is given by the formula N equals R times T. This relationship is known as Little's Law. The owner of the Good Deals store estimates that during business hours, an average of 3 shoppers per minute enter the store, and that each of them stays an average of 15 minutes. Right. The store owner uses Little's Law to estimate that there are 45 shoppers in the store at any time. So that makes complete sense. The owner of the store basically used the formula n equals r times t, which, by the way, I'm just going to write down. N equals r times t to figure out that there were 45 shoppers in the store at any given time. So we have r, and looks like it's a big T. And let's be very clear that n is the number, of shoppers in the store at any one time. So I'm going to write that. And we also know that R stands for, the amount of customers entering the store. Let's see, looks like it's shoppers per minute. All right, so the amount of shoppers that enter the store per minute. So I'll write that as well. And finally, this big T, according to this, represents how long. Let's see, the average time in minutes, by the way, that, the shoppers stay, right, in the store. So I'm going to write that as well. So that right there is the formula. And then they talk about how the owner of the Good Deal store estimates that during business hours, an average of 3 shoppers per minute enter the store. So that's R. They, each stay an average of 15 minutes. So that would be T. And of course, 3 times 15 gives me 45, or gives him 45, or her 45. So that's 45 shoppers in the store at any time. Okay, Little's Law can be applied to any part of the store, such as a particular department of the checkout lines. The store owner determines that, just make this a little bigger, determines that during business hours, approximately 84 shoppers per hour make a purchase, and each of these shoppers spent an average of 5 minutes in the checkout line. At any time during business hours, about how many shoppers on average are waiting in the checkout line to make a purchase at the Good Deal store? Well, the first insight, you need is that, these shoppers who are making a purchase, well, where do they do that? They have to do that in the checkout line, right? Now, according to this, it says that this law, in other words, this formula can be applied to literally any part of the store, including we can use this formula to analyze like what's happening in the checkout line, okay? So, for example, we could figure out the number of shoppers in the checkout line at any one moment, depending on how many, people enter the checkout line, per minute, and the average amount of time they spend in the checkout line, right? The amount of time in minutes that they spend in the checkout line. So the problem is that they say that, like, essentially what they're saying is that 84 shoppers per hour make a purchase. That's their way of saying 84 shoppers per hour are in the checkout line. Okay, that's the way to read that one. Okay. But the problem is we want the number of shoppers who enter the checkout line per minute, not per hour. Right? So 84 shoppers per hour, this is where you could kind of do a unit conversion. This is the first time in this video that I'm actually doing a unit conversion in the following way. But I kind of like this approach. So we want to know how many shoppers per minute are in the friggin' checkout line, right? Not how many shoppers per hour. Well, according to them, there's 84 shoppers for every 1 hour. Now, I'm curious about shoppers per minute, not shoppers per hour. So what I'm going to do is I'm going to multiply this fraction by another fraction. And it has to be a fraction that has hours up here, such that literally the word hour will cancel with the word hour here. So what I could do is I also want to feature minutes in general. So I could say, 1 hour right here is, corresponds with 60 minutes. okay? Because I want shoppers per minute, not shoppers per hour. So I'm setting the stage. I'm taking this relationship here that they gave us, and I'm multiplying it by a fraction that will cancel the word hour out. Now, I'm not as interested in canceling the ones out. It's the word that's the problem, okay? So we're going to do that. We're going to kind of work this out. And, of course, the words, the hour word cancels. And I'm therefore left with a 1 and a 1, and I have 84 shoppers, and I have the word minute. I want minute on the bottom. So this ends up becoming, through the magic of unit conversion, 84 over 60 shoppers, per minute, right? Well, now you could just reduce 84 over 60. They're both even, right? So that would be 42 over 30. And that further reduces to 21 over 15. And that further reduces to 7 over 5. Now, 7 over 5 in decimal form is 1.4. So this ends up becoming 1.4 shoppers per minute, right? Per minute. Okay, so that's a nice way of doing unit conversions. Basically, they tell us that it's 84 shoppers per hour in the checkout line. Well, we want to know how many shoppers per minute in the checkout line, because we want to know the number of shoppers who enter the checkout line per minute, right? And then we're going to multiply that times the average amount of time they each spend in the checkout line. Then we're going to get our N, which, by the way, is what they're asking for at any time during business hours, about how many shoppers on average are waiting in the checkout line to make a purchase at the store, also known as what is N, what is the number of shoppers in the checkout line at any one moment, right? So we're going to do that right now because we know that we can set up the equation that says N equals R. Well, what is R? R is the number of shoppers who enter the checkout line per minute. We just figured that out. It's 1.4 shoppers per minute. So that's 1.4 times the average amount of time in minutes that each shopper stays in the checkout line. It's going to be T there. And we know we can, again, apply this not just to the whole store, but to the checkout line, because according to the first sentence, Little's law can be applied to any part of the store, including the checkout line. So it's going to be 1.4 times the average amount of time in minutes each shopper stays in the checkout line. And that is 5 minutes, according to this information here. It literally says each of these shoppers spends an average of 5 minutes in the checkout line. So that's going to be times 5. And that ends up equaling 7. So that is the answer to problem number 37 about how many shoppers on average are waiting in the checkout line in the store at any given moment. Well, that would be 7. We used the exact same formula. We applied it to the checkout line. They told us that it was 84 shoppers per hour in the checkout line. We had to convert that to how many shoppers per minute. Well, that's a unit conversion that we could just kind of apply here. 84 shoppers over 1 hour times making sure that we have the hour word up here, apply it, correspond or correlate that to minutes. Obviously 1 hour corresponds with 60 minutes. We were able to cross out the word hour and then just multiply straight across, and then we had shoppers per minutes left over, shoppers per minute. And then we put in that number, 1.4, in for our R, because R needs to be shoppers per minute, not shoppers per hour. Okay, so that's how that one works. So I'm going to erase all this, and we're going to get to problem number 38. I'm probably going to leave this, but I'm going to erase this stuff, and we're going to get to problem number 38. All right, so the final question. Let's take a look here. The owner of the store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store, and each of them stays an average of 12 minutes. The average number of shoppers in the new store at any time is what percent less than the average number of shoppers in the original store. Note, ignore the percent symbol when entering your answer. For example, if the answer is 42.1%, enter 42.1. Yeah, so in the grid in box, just put in 42.1 for the percent. Now, at the end of the day, what are they asking? I'll actually highlight the final question. The average number of shoppers in the store at any time is what percent less than the average number of shoppers in the original store at any time? Well, first, it'd be nice to know what the average number of shoppers in the original store is, right? Well, the good news is they actually gave us that information in the beginning. That is right here, right? They talked about how the owner of this store used this formula to figure out that there's 45 shoppers in the store at any given time. So in other words, the big N equals 45. That's for the original store. So I'll just write that, the original store is, I'll write OG. The OG store, 45 shoppers at any given moment, right? So if we could just find N for this new store, if we could just find this big N for the new store, then we could compare it to 45 and then figure out the percentage change, okay? So, according to them, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store. Well, how many shoppers per minute would that be? Because that would enable us to figure out what lowercase r is, the number of shoppers who enter the store per minute. So we're going to do a similar process, unit conversion, 90. I'll just write shop for shoppers over 1 hour. This is a bit redundant, so you might even just remember you have to divide it by 60, but we'll get the additional practice. And we're going to have 1 hour over 60 minutes, and the purpose of that is to cancel those, and therefore we end up with 90 over 60 shoppers per minute, which is R, because once again R is the number of shoppers who enter the store per minute. Well, in the new store it's 90 over 60 shoppers per minute, and that turns into a decimal that is 1.5 shoppers per minute. So I'll just write that to be thorough. Now that right there is R, right? That's the R for the new store, right? We're analyzing the new store. Here's the equation we're going to use for the new store. We want the number of shoppers who enter the new store per minute. Well, we just figured it out. We know that in the new store, 90 shoppers per hour enter, and that turns out to be 1.5 shoppers per minute, right? And according to this, each of these people in the new store stays an average of 12 minutes. So we're going to use this formula and figure out what N is. So we have R, which is 1.5. That's going to be multiplied by 12 minutes, which is the average amount of time each customer stays. And that turns out to be 18. So N equals 18. Okay, so the big N, as a reminder, means the number of shoppers in the store at any one moment. And at the end of the day, we want to know, the average number of shoppers in the new store, which by the way is 18, at any time, is what percent less than the average number of shoppers in the original store, which was 45. OG is 45, right? So we went from 45, I'll kind of dress these up in a new color. We went from this to this, right? And yeah, what percentage change is that? Well, this is where you could use a pretty cool, trusty formula to find the percentage change. And here's the formula. It says the new amount minus the old amount, all over the old amount, times 100. That will give you the percentage change. Now, if it's the case that this calculation results in a positive number, then it's a percentage increase by, a certain number. If the calculation gives you a negative number, that is a percentage decrease. So the new amount in this case, is 18, because we went from 45 to 18, right? This is the original store. This is the new store. The old amount is 45, and we want to know the percentage change from 45 to 18. So clearly it's going to be a decrease. And working that out, it would be such that it's 18 minus 45, all over the old amount, also known as 45, times 100. And let's see what that becomes. 18 minus 45 is negative 27. So up here is negative 27, and that divided by 45 is negative 0.6. So this whole thing ends up being negative 0.6. And that times 100 is to move the decimal place over twice to the right. So, in other words, I'll break it down. So this became negative 0.6, and then we have to multiply that times 100 and do a little question mark. That ends up becoming 60, and it's really a negative 60, right? So that is a 60% decrease due to the negative number. So whatever this number is, because you multiplied it by 100, that's actually like the percentage. It's 60% decrease due to the negative number. Okay? So this is a great formula to use if you want to find like the percent change between a new amount and an old amount. New amount minus old amount, all over the old amount, times 100 gives you the percent change. If it's positive, it's a percent increase. If it's a negative number, it's a percent decrease. In this case, we have a 60% decrease. Now, let's see, in the actual problem, so negative 60, that's like, in a way, the answer. You could say 60% is the answer. 60% decrease, at least. Let's see what they asked for specifically. The average number of shoppers in the new store at any time is what percent less. So they're already taking into account that it's less, right? So they're like, what percent less is it, right? Well, the answer is 60. It's 60% less. Okay, that's what we just discovered. All right, so that is the answer to that one. And I hope this video was very helpful. Again, this is an example or various examples of the kinds of problems that you might have to face on the SAT math calculator section. Also, take note there are 38 questions here, right? That's what you're going to find on the calculator section of the SAT. So hopefully this was helpful. If I made any careless mistakes, which I do not think I did, but if I did, please comment below, let me know. If you have any questions, comment below and let me know. And I will talk to you soon. Good luck.